All right, here we go. Okay. Is it a hump or a drop? What do you say? You got to twist your words in every which way, because the motto will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line or does it curve? Some people unclamp it, but that is absurd. We all know that the model will always dictate what you do. Everybody knows that you are model afflicted blue. Model affliction. It's your addiction. That model affliction. It brings you so much pain. It's your ball and chain. Conflating curvature with elevation change has got your local distance just out of range. That old biggie is gonna dictate everything that you do. And everybody knows that you got the model affliction blue. It's your decision defending the model position. You just don't know the geometric proposition. That old ball, it'll always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction. It's your addiction. Model affliction. It brings you so much pain. It's your ball and chain.
World famous Buster. And we are live. Welcome everybody. It is a Model Affliction Monday and we've got some special guests today. We've got Elder Bear, J-Ro, Kevin B, No-Rad, and Rob Keane. And not forgetting Emma UK. So welcome, Model Affliction Monday. Like I said.
Good afternoon. I'm the most model afflicted one here.
Well, apparently everybody's model afflicted. I think you have to be. It is 2024. We did have a conversation this morning. We will be going over that. But we've had Blue Marble in over the weekend he must have been a bit lacking on something to do. So he's been around this weekend, no doubt, drumming up a bit of model affliction of his own. And we had a visit this morning from a long time YouTube comment chat troll, we would call him. But I mean, I don't think we could say that anymore, because, as we say, we'll be going over a conversation that we had earlier. Mr. Sparkles, what does model afflicted mean exactly? Just so's we're all starting off on the same page. Well, Model Affliction Monday's been going for years. I mean, you want to start off on the same page. Model affliction is when you allow a model to dictate reality to you, rather than just accepting reality as is and placing that upon your model. You allow the model to dictate reality to you. I think that's where we've been at. I've been fascinated by a certain arena over, well, I think it's got to be going on 6 years now. It's got to be. We went over a video this morning that was 5 years old. So that, since that was recorded, pretty much, well, a fair bit into us actually being here recording these sort of events, conversations that we've had.
Time flies when you're having fun.
Yeah, it's a long time, right, to realize. I mean, I've been Mrs. was saying that I've been flitting from one thing to another, but with this, seem to have stuck at it because, well, I don't know, is it like a hobby? Fascination. I think I've learned more within this arena than I've ever learned the rest of the time. Personal growth, right? That schooling stuff is slightly different than what I've learned around here. I think there's a lot of learning to be done about yourself within a conversation, particularly around talking to people and being able to communicate with people. That seems to be what's lacking, and what I personally came here for really was to learn how to communicate with people, and it's going good. We know there are we're all on a journey through life, and I think everybody would definitely say that this is a fascinating arena to be in. We've got Mr. Sparkles back again. We're all somewhere along the particular strip, I think. Yep. Yeah, that's what it's all about. It's about learning how to. For me, it was about learning how to implement the mathematical thought process, because I'd always considered myself a pretty mathematically minded person, but never really strong within, call it English, but within English language, communication, storytelling, that sort of stuff. I never really saw the use in that sort of stuff until coming round here and learning that communication and logic is a lot more linguistic than at first realised. And that's mainly the journey that we've been on. The simplicity of what we do round here is well, that's why we're all here. Yeah, he said the maths is something that's conspicuously absent. Well, it depends what sort of mathematics you're talking about, because there's a lot of people that are very skilled within mathematics at the number form. But what we try and do here is we try and simplify it down into the simplicity, the base mathematical understanding, formulating from first principles. And this particular arena seems to be filled with people that have built upon the complexity of other things. I don't know if anybody managed to listen to the Terence McKenna thing. And I think that's where we're at around here. So, like we say, there's a conversation we went over this morning. Has anybody got anything else to say about anything that's happened over the weekend or anything?
No, but I'm still waiting for an opportunity to go over the Jordan Peterson contradiction stuff, but it can be later. I'm a little busy right now, but I want to do that today if we could, because dependent on the model affliction.
Okay. Yeah. Well, whenever you want. Yeah. Come on.
Yeah, I'll post it. Yeah, 100%. It'll be before the end of the day.
Also, I love being a special guest. Thank you for having me.
Well, yes. Anybody else wants to come on in? This is Model Affliction Monday. You too could be a special guest. Just click the thing. I think we're about to be joined by Paper Organist. We are. Paper Organist has just entered the building. So, again.
Hello.
There you go. Look at that.
Evening, Paper.
Mr. Sparkles, I don't know whether you think about that. Like, I wouldn't say FE runs screaming from mathematics. That's one of the things that I always thought was dead strange, that, you know, people say that flat earthers don't understand mathematics. Well, everybody's an individual, and yeah, there are people who are very skilled at mathematics. Not so much logic, but yeah, people can do mathematics equations. They're just ordering things, and there's all sorts of different abilities within this. So I wouldn't try and say that one particular group of people aren't very skilled in mathematics. It's a bit of a silly thing to say, slightly bigoted, and we try and keep away from those sort of things around here. It is Model Affliction, but I try not to place it upon a group of people. Keep it to, you know, the people, the subject that you're talking about or whatever. Okay. Right. So, we need a backstory. We were visited this morning by Stefan Mudd. Now, this is an ongoing thing that we've been talking about, and Stefan Mudd obviously hits upon the conversation that he wanted to be talking about, which was this. Well, as we say, you can do fuck all with an angle. Meaning, with one single angle measured by a sextant, you don't really have any way of deriving anything geometrically from that one angle. And that's what Stefan's going to be talking about. Now, as you'll hear, it's quite a familiar story when asked when people are asked about this particular thing as to how people derive whatever it is. Now, there's never really much of a conversation coming back again from this, these statements. So at any time, if anybody's in here, anybody wants to pause it, obviously I'm part of the conversation, so I won't be pausing it that much. So you guys will have to let us know. This is being a model affliction, so we'll keep it associated with that if we can. Let me get these screens sorted out. I don't know whether you necessarily need the screen on for this sort of stuff. This was recorded earlier this morning.
You need the screen on if you want to hear it.
Pardon?
You do need the screen on if you want to hear it. At least I do, anyways.
Yeah.
If I don't click on the video.
Yeah, I'm talking about the YouTube peoples. They don't really need to see the screen, so everything that will be posted in the live chat will be up for people to see. Post your GIFs, your memes, or whatever. And right, yeah, this was recorded this morning, so here we go.
How are you guys doing?
Good to explain yourself. All right. So, like, you've been fascinated with us. Can you let us know why you're fascinated with this particular thing?
Yeah, quite a few things. First off, as the psychology of and the way you think. Another thing is the logic you try to implement. That you seems to forget the starting premise has to be correct. You can always have a logical, how do you say it in English? Do a logic layout, but unless the starting premise is wrong, the conclusion will be wrong. Yes.
Well, the first principles
Basically
is the straight line, right? That's always been our first principles.
Yeah, well, I don't think I agree, but I've asked you quite a few times about this claim of yours that all horizontals on Earth are parallel to each other, even by distance.
Even the ones like that aren't on the Earth. Like I've said, all of them. The ones in the air.
No, hang on. You're still trying to deflect for answering this question directly. And I asked you a few times. Let me give you an example. Do you actually think that the horizontal at the North Pole is parallel to a horizontal at the equator? Yes or no?
Yeah, all.
If you can't answer yes or no, I just leave.
All horizontals, yes. We've had Betty do this. The swimming pool question, I think Betty called it.
I didn't ask what Betty said or had done. I'm asking you. Mm-hmm. What is your claim?
Oh,
do you claim? Do you? Yes or no question?
For every one of them.
Okay. Which means going from the North Pole to the equator along the sea, that would be more or less a continuous horizontal plane, wouldn't it?
I wouldn't know. No, wouldn't know. All I'd know is that how to establish a horizontal plane.
Yeah.
Right. And the fact that all horizontals are parallel to the plane of the horizon.
Yeah. So first you say, yes, you think that the horizontal at the North Pole is parallel to the horizontal at the equator.
Yeah, just put X.
And I said, well, really hang on, let me finish. In that respect, that means that the sea from the North Pole to the equator must be more or less like a horizontal plane. You can't have much of an elevation change because then the water would go to one side, wouldn't it?
I wouldn't know. There's tides and all sorts of stuff.
Forget tides on the average.
Within a range, I would say. Yeah. Within a range, yeah, you've got to have...
within a range, yes. That's what I mean.
Fluid dynamics would dictate.
Yeah. Then I have a question for you. regarding Polaris. We know that Polaris is about 433 light years away.
It's just a light
Measured
in
by-
the sky to me. I wouldn't
It's
say how do you
it
know
is, but-
that? Okay, 433 light years. Imagine coming up with that. That was Stefan.
Time distance. Okay.
Yeah. And he said, we know. Well,
So, it
was
is
me.
funny because we have two assumptions. First, that we know distance to the star. The second, we know the speed of the light because years are referring to known speed of the light. So this is double begging the question in his statement. That's my interjection.
and well, he says we know. Now I don't
Yes,
know.
we.
That. I don't. know that.
General we. Yeah.
Well, I'm not part of that because, like I say to him quite a few times,
Me too.
I don't
I'm
know
not
that.
also.
Don't include me in that group of people because just don't.
If you go and check and see
No,
how they've done
no.
the different measurements.
You said we know. I don't know that, so I'm
Yeah,
asking you.
Okay,
How do you know
let
it?
me inform you there. Okay, let me inform you. Could you please look up Hippocrates or Gaia satellite missions?
Sorry.
Hippocrates and Gaia satellite missions. You ever heard about them?
No.
Do you know what a Cepheid star is?
No.
Okay.
Is it a light
No
in
wonder
the sky?
you think it's. Yeah, exactly. You have absolutely no idea, so you think it's just a light in the sky. Well, I don't care. The measurement shows that they're 433 light years away.
What
and if the
measurement?
horizontal, and hang on, let me finish, because I got short of time. So if the horizontal,
He's short on time. He stays for
As,
2 hours.
as always, yes.
He does stay for 2 hours, but
Yes, but when things goes wrong, so he is short on time. Okay.
a measurement again.
at the North Pole is parallel to the horizontal at the equator, you would have to move 7.6 light years away from the North Pole to just measure 1 single degree change of elevation angles. Please explain this based on your.
I don't get that. Do you want to go over that again?
Yeah, I'm actually talking about Euclidean.
Okay,
Just
so
now,
how
by the
do
example.
you know that you've made a measurement of that distance then?
Oh, I've measured the elevation angle from Tromsø in Bodø and in Ålesund, which has a distance about 900 kilometers between them. And as I calculate from different distances and the change of the angles, it ends up approximate, from my calculations, about 111 kilometers between 1 degree.
So you're talking about a difference of angles.
By distance from the North Pole.
Is that like the sine? Or, you obviously you can't use the law of sines, can you? You couldn't.
I don't have to.
No, I know, but
It's
in
quite
order
sti-
to get
no,
your, what was it?
Hang on. No.
Billion.
Let's
I don't know.
let's stick to straight lines and Euclidean geometry.
Well, distances are straight line distance. That distance that you quoted, that's a straight line distance, right? Anyone got any idea what sort of lengths and angles you would have to measure in order to get a distance of 433 light years?
It is begging the question again because he has to assume that first assumption is that the star is bigger than Earth, and because he has to assume parallel light rays incoming to Earth, which is included in their spherical model. This is first assumption. Second assumption is that we live on a sphere, of course, because he is making this angle by declining. So he is moving away from this light in the sky, and he is moving in curved path. So this is second assumption. And the second assumption is also wrong because we are making always, we make calculations with straight lines. So the second assumption that we are living on a curved surface is you cannot use that in that calculation. So it is just error. You cannot do that.
Yeah, I don't think he's never mentioned any of those assumptions though. So
Yes, I am because I know the topic from that side, so I know what he is doing.
well,
Yeah,
yeah,
but you
can we
yeah,
try
can I
and not doing that? Go on.
yeah, I was gonna say the same. Can you guys hear me all right? Because I'm in the car.
Yeah.
I was just gonna say the same thing. With all due respect to Paper, who's very knowledgeable about this stuff, right? We can't put words in Stefan's mouth. Now, he talked about a distance to a light in the sky. Does anybody here want to claim that they actually know a distance to a light in the sky?
No,
An
no.
actual distance? Then the answer to Bev's question is no. Can't happen. It's a not that. Talking about the not that and explaining how they get the not that is useless. Absolutely useless. In my opinion.
I agree. Yes. I agree. I am just talking about model and delivered numbers from someone. So
Well, I think it would be better if they do it rather than we do it, because you know how it works. Like for the next 2 weeks, we'll be talking about what you've said and your assumptions that you've just made, or your assumptions of their assumptions, rather than the conversation that we're attempting to talk about.
To be honest, it is very old. So he's not talking about new things. So this is old as this flat Earth, let's say, topic like 10 years or 8 years. So it is from the start. So I'm not saying anything new here.
Well, you are to us. I bet there's a lot of people that are in here that have never heard that. And now they've heard you say about it. That they might associate, if that's the first time they've ever heard it, they might associate it with you.
That would be strange for me, that people don't know these claims. And by the way, Baby was talking about, when he was talking about Eratosthenes and his 6 assumptions. So one of them, it was that the light in the sky is very, very distant. And the second one was that lights incoming are parallel. So this is not me, not now.
Yeah. Right, well, we'll carry on. Assumptions. I try and get Stefan to say all of this, but I mean, it's hard work, because what I've found is a lot of people rely on, let's say, flat earthers to say about their model rather than them, because they don't like saying it, because it does make them sound ridiculous.
I agree. So if I were talking to Stefan Wood, I would not tell him that. I'm just telling now because I'm not speaking to him. But in conversation or some kind of debate, I would never say that, because this is not my cup of tea. This is their model, not mine.
Yeah, well, it's, like RH says, who discovered that light can travel that far? I mean, that is a pretty big assumption. I wouldn't know how you would discover that to start off with.
No, it's a distance of the surface of the Earth.
No, to the light in the sky. Your
That
original
is a distance,
when you said we know, and I said I don't know that, how do you know it? That distance.
by going by the science of people who has the equipment and know how to do it.
But that would be geometry, right? A distance measurement. That would
Yes.
particularly be geometry, except a geo is Earth, right? But you're not talking about that. You're talking about distance to a light in the sky. So you can't necessarily be using geometry because
but we know the distance to Polaris.
we don't.
By
I
several
don't.
methods.
This is why I asked you.
I don't care.
how do you
I don't
know it?
care if you don't know. Bav, I don't care that you don't know. You just claim this
No, you've
as
just
an excuse
claimed it,
because
not me.
it gives you so. No,
you've just claimed
the
we
reason-
know, and I said I don't know that. How do you know it?
To be honest, you use this claim you don't know as an excuse to get away from the problem it creates for your model.
No, literally,
It's
I
as
don't
simple
know
as
how
that.
you
It is
measured
as simple as that. Oh God, Gaia mission. You never heard about the Gaia mission?
No.
No. Okay. Not Hippocrates split mission.
No.
Parallax.
Heard of parallax, but parallax
You know what
of
it
the
is?
light in the sky, the distance measurement.
Parallax of the. Yes, you can. Yeah, that's simple geometry. Have you heard about?
There you go. So parallax to measure a distance of 433 light years. I mean, quite a long way, isn't it, for one of the
Parallax is visual, so it is, let's say, phenomenon inside of perspective, let's say, because this is one of the features of perspective. It is called parallax. So, yeah. So what?
You see how upset he's getting already because you're challenging his knowledge of a distance that he claimed. Now he's trying to tell you that there were these satellites and these scientific, quote unquote, scientific projects that were done that calculated the distance, assumed the distance, let's say guessed at the distance based on this, that, or the other thing. And maybe he'll get to it, maybe he won't, because I haven't heard it. But you see how upset he's getting and trying to put it back onto you, Bev, that you're just using it to avoid talking about your model when you've said a million times you don't have a model, while he's avoiding the direct question about an actual distance to a light in the sky, because that's his model. This is absolute projection by Stefan, and it's not at all surprising at all.
Yes, they don't know their model. So that's the problem. Problem number one, they cannot present their model.
Hang on, Paper. I have to disagree with you. They know their model. Their model is fucking ridiculous. The idea that he's arguing with Bev about a known distance, a distance that can be known to a light in the sky, is utterly ridiculous. But he has to say that for the sake of his model. So he knows his model. He's going to bring Gaia and all the other stuff that he's talking about, the satellites. That is their model. So they know their model. Believe me, he knows what he's talking about. The issue is that what he's talking about is not that. And he's getting angry with Bev because Bev is already painting him in the corner of, we're not going to accept you're not that. Sorry. So where's your actual, how do you actually measure 400 and whatever he said million light? Yeah. Would you care to explain what geometric tools or surveying tools you might use to provide that distance, to know that distance? Who's been there?
It is impossible. He cannot.
Of course it's impossible. He knows it's impossible. He's getting upset already.
Yeah, I don't mean to get people upset. It's just that when somebody says, we know something, and I don't actually know it, I can't place myself in that group of people that know something. I can't know something because other people claim to know it. If I don't know it, I don't know it. So I would like to know it. So I would like to know the method that made them able to do that. Now, I think it's impossible to measure a distance of a light in the sky. So if anybody has claimed that they do know it, I would really like to know the method that they are able to do this impossible task, as I would call it. If you think it's possible, come on in and explain it to us. I still have the opinion that it's an impossible measurement to make.
Very long baseline radio interferometer. Hang on.
Again?
It has been varied, but the distance is more and more accurately being measured.
Okay.
From the Gaia machine,
so
which is
very
the most
many measurements to be able to be had to a light in this. You noticed he said there as well, more accurate, and he said 433 light years. So at least within a light year. Well, I don't know what any of the other measurements were. That's the first time I've ever heard anybody come up with a measurement to that particular light in the sky. Never heard any measurements really of any other ones, but more accurate apparently. Sky, right?
It's not a light in the skies. What? Could you please stop calling it a light in the sky? You know as well as me it's a star.
Calling the light in the sky a light.
We know this.
You call the light
from
in
the
sky. Yeah, it's a weird one.
That was funny. Yeah.
Yeah.
Please don't call light in the sky light in the sky. Okay.
That was awesome.
From the radiation, from the electromagnetic radiation coming from the star, it's even a C5 star. You don't even know what that is. So why in the hell are you just calling it light in the sky and not listening to what information?
You know something you claim to something.
I've read the scientific papers, and I understand how it has been done. I understand the mathematics they used. And now the physics of the stars, the measurement of the electromagnetic spectrum.
Physics now as
well. Spectroscopy. I know what a Cepheid star is, and I know that Polaris is a 3-star system. But anyway, so we know the distance. I don't care if you say you don't know. I don't care. But the rest of science know the distance.
But the only way of doing that is by triangulation, right? You can't do it with a square.
Yes.
You need a triangle.
No. It's yes. You're right.
No. Is it that a no or a yes? The only way
triangulation.
You can predict distances is with a triangle.
It's several, but parallax. That's a main measurement which has been done. Okay. But it also ties into what we know about Cepheid star. The Cepheid stars are variables.
So you mentioned 900 kilometers?
900? What are you talking about?
You said, because I'm just trying to work this triangle. You measured 2 angles from 2 different places. And I
did, yes.
Okay.
1100. But that doesn't give me the distance.
The
my measurement doesn't give the distance.
No.
Yeah. That's not how you measure the distance to a star.
Triangulation, right? Angles.
Parallax. Angles, yes.
Yeah, well, that's what
angles,
I said.
Baseline.
Parallax would be using the law of sines, right?
Yes. And you use satellites which travel far off. Yeah. Of course, it's calculations. But remember. It's not just.
So what number did you come up with then?
Which tells. Well, let me try this again. The change of elevation angles that I've got tells me nothing about the distance to Polaris, unless the surface of the Earth would be a horizontal plane. Problem then is that I would get different elevation, and the problem is I would get different.
Though, right?
No.
You know that.
You know what?
That the surface of the Earth is not a horizontal plane, don't we?
Well, if you establish horizontals, would they be
parallel?
Yeah, exactly, which means if I establish horizontals along the way from Tromsø to Ålesund, they should all be parallel,
They will be.
done by the sea. Yes, okay.
They'll be both parallel
Then you
to
have to
the
explain to me-
horizontal that you established before and the one that you're going to establish after, all the way along the way. All of the
Yeah, so how
horizontals
do I get-
will always
so-
be
so-
parallel.
Yes. So so my horizontal where I live is parallel to the horizontal in Tromsø. That's your claim.
Yeah, all of them.
Okay, fair enough. Then we could use my measurements or any other
Your measurements.
measurements of
What
elevation
measurements have you made?
angles and distance. Hang on.
Mhm.
Elevation angles and distances. Problem is then we end up with a right angle triangle. And
Where you get a right angle
using
measuring an angle.
Polaris has a GP, yes. There's
No.
a place on
Lights
Earth
in the sky
where
are
you can
in
be.
the sky. They're not on the ground.
Oh God, well, that please don't be this ridiculous. You know exactly what it's
What,
meant.
the lights
It's a
in the
position
skies,
on
they're
Earth. It's
in
a
the sky.
position. Hang on, no. It's a position on Earth where you at a specific time will be directly under a star.
Don't be stupid, man.
Have you been outdoors on a starry night,
Yep.
Dev?
I have, and looked up
Have
as
you
well,
looked
yes.
Yeah. Have you seen a star being close to straight above you?
I wouldn't know. Like, there's loads of fucking lights in the sky up there, isn't there? And they move,
That's
don't
not
they?
what I asked. That's not what I asked. Yes, they do move.
There you go.
And the thing is,
So do you think you
all
could
of those
measure
lights
an
in the
angle to a
sky
light
at some
in the sky
time, hang on,
while it's
some time will be directly above an observer. Depends, of course, on your position on Earth. It doesn't matter. But at the North Pole, just less than a degree away from the North Pole, you will be directly under Polaris
So not at 90.
at a specific time. It will be the line from the horizontal
Is that the
to Polaris
geographic?
straight up will be 90 degrees.
So there's a location that's marked. Is
Yes.
there? Polaris.
No.
Look up.
No.
Polaris is there.
Yeah. And if we know it's it's about a half a degree away from the rotational axis of the geographical North Pole. If you move
So
half
the
a degree,
geographic, not
to the
on the
side.
geographic then.
Pardon?
So if you were at the geographic, it would never be above you.
No, it would be. No, it would be like half a degree away. But if I then move half a degree, hang on, half a degree is about what?
Confirm that.
About 50.
So here's the first mention that the claim to be 90 degrees isn't actually a 90.
Yes, something weird going on with him because, and by the way, I am not sure about this half of degree or whatever because in star trails I have never seen that Polaris making it would make ellipse if I am for example at 45 degree to Polaris, it will never make a circle from my point of view. So for me it is just a claim that is not supported anyway, and I don't believe that half degree and that Polaris is rotating around closely to that point in the middle of whatever.
Well, we've been talking to Beddy, and he says 89, yes. 50 minutes. So it's more like 3/4.
Yeah, but of course you can let's say blame refraction or whatever. But anyway, in for most observers, this rotation of Polaris would create not a circle but some kind of ellipse. So, and it doesn't.
Again, well, I wouldn't know about that. It's like I say, it's just a light in the sky. They call it
Yeah.
the North Star, but
Yeah.
apparently, it's not quite. So whenever you hear anybody making a 90 degrees, you'll be able to tell them from now on that Stefan Mudd has said it's not at 90.
Yeah, but for me it is just excuse because these numbers with nautical miles they don't add altogether, so they are just creating excuse. Oh, it is not exactly, but you know, closely, but not 90, close to 90, but someone can argue. For me, it is just excuse.
Well, that's what we're here for, isn't it? For the conversation. Just letting people know. You might have heard of a certain group of people making a triangle from measuring an angle. Now, Stefan will try and do that. He'll try and put a 90 degree on the floor. I say lights in the sky are in the sky. They don't make it to the ground. And Stefan will later on be saying there's a 90 degree on the ground. Well, he's just said, particularly to Polaris, it's not 90. So anybody referring to Polaris for a 90, Stefan's just said it isn't.
55.5 kilometers. So if you move 55.5 kilometers away from the North Pole and you wait
In which
as
direction?
Polaris rotates around
South,
at the
obviously. If you move away south, yeah,
you can't go north of north, can you?
Which direction is south?
Any direction from the North Pole. You can't go north of north. That's quite simple.
Did you
What a
say
stupid
any
question.
direction?
From the North Pole.
Yeah.
How the only way you could go without going south would be straight
you sound
up.
like a flat earther. Are you sure you're not a flat earther?
You can't be this ignorant or pretend to be. If you're standing in the middle of, hang on, if you're standing in the middle of the North Pole, if I take a step towards the left, right,
how
back,
big is it?
It's a single point.
Oh,
okay.
Right. You're standing in the middle of it.
Yeah. So yes, I'm standing in the middle of it. I take a step to the right or the left or forward or backwards.
Yeah.
Will I be moving south?
I wouldn't say so, but
will I be moving south?
Is that what you imagine?
If Polaris isn't at 90 degrees above you, and you have to move further away somewhere else for it to be there, are you moving north from north in order for that to be so?
South. How you can't go
Polaris
north.
Isn't at the North Pole then.
Let me just get this right. Let me just get this right.
God.
If you're at the North Pole, you have to travel south in order to get the Polaris above you.
Yes.
On your model.
Yes. Yes.
Okay.
Yeah, that's what I was asking. Basically, you're not moving north. You have to move south to go to the north to be more direct and specific.
No, that's what I've been saying all along. Polaris is about half a degree away from the North Pole. Which means if I'm standing directly on the North Pole,
where it is 90 degrees above, you've got to go south.
Can you let me explain, please?
Right. It gets a little bit complicated, this. So, if you hear people saying 90 to Polaris, the actual North Pole is south, but it's not because it's north, isn't it? But it's south of the position, possibly. of where Polaris actually is, because like he says in a bit, it's a circle of not a point. It's 55 kilometers. He says 55 kilometers, but I think it's more than that. I think it's more like 100 miles, I think.
He seems pretty incredulous at the fact that he's being challenged on some place that he's never been himself.
Yeah,
I
for a
find
measurement
that
that's never
very
been
strange.
made.
Yeah, yes. It's like, Stefan, have you ever been to the actual point of the North Pole? You yourself? Well, no. But I'm going to tell you how it works, though. And he's incredulous that anyone would be challenging on this. He can't see that. Well, they're challenging me on this because I've never been there. I've never done these things. But I'm now going to quote educate unquote them on things that I've never done before.
Yes. I've never done it either. I've never been there to verify that. I don't know whether anybody has ever measured any star above their head at 90 degrees. I mean, how would you do that? How would you purport to do that? Does anyone know? How you would I mean, could you phone in and say, oh, I've just spotted this star above me? Like, put it in on the almanac, right? If you ever want to use it.
Could you
That was going to be my next question. Real quick, just how would you even know where the geographic North Pole was to move south from it to get to the GP? I don't.
Yeah.
And
okay.
Absolutely. And is the geographic North Pole the same or different than the magnetic North Pole? Does anybody know this for sure?
Well, there's three different ones.
I don't know, but they say that it is different.
Yeah.
They say that it's different.
Yeah, but I have no clue.
But Stefan is talking about Polaris being over the geographic North Pole, yeah?
No.
Yeah, he did agree with Bev that there's a sign there that pointed upwards. Saying there it is.
That's exactly what I'm wondering.
Look up.
Yeah, look up. But not quite up. A bit over there.
Yeah. Go over there 55 kilometers and then look up. And it might be there. But it could also be somewhere else.
If I'm at the North Pole, I measure the angle to Polaris. It's about 89.45 degrees. If I move to the side, south, just a tiny bit, about half a degree is about 55 kilometers. Then, since Polaris is rotating around, at a specific time, Polaris will be straight above me. It would be 90 degrees from the horizontal up to Polaris. This can't be that hard to understand.
Right, so that's a horizontal being horizontal and vertical being perpendicular.
Yes.
Right, and would that be true of everywhere at 90 degrees?
Yeah, well, no.
What shape would you make?
What shape of what?
If you were to have that 90 degree that you call if you're at the place where you imagine the light in the sky is directly above you, don't know how you'd measure that, but you were to do that,
problem.
And you were to follow it. Yeah. So it constantly did that out for how long? 24 hours, so let's say?
I don't have to follow it. I just need one.
No, I was talking about to do this mental picture, right? You've got Polaris that you say isn't at the North Pole. And you're going
half a degree off.
You're going to follow it half a degree, right? So you're going to follow it at half a degree.
No, I move away from the North Pole.
No. Let's just follow the GP of the North of Polaris, right? For a day.
Yeah.
What shape would we make?
It would be a circle.
Okay, now all of those points on that circumference of the circle would be at 90 degrees. So therefore, you would have a vertical and a horizontal.
Yes.
Right, on both sides of that circle. In fact, all the way around that circle.
No, it's 90 degrees to the local vertical.
Yeah. So that's what I'm saying.
The horizontal. Yeah.
Or at every point of that circle, you would have a right angle there, right?
Yeah. Yes.
Okay.
Yeah.
Of the light in the sky.
Yeah.
Okay. Now that circle is a traditional Euclidean circle, right?
Yeah.
So
what?
The plane of the circle, could that be considered horizontal?
Yes.
Okay. So therefore, if the plane of the circle is the horizontal, all of the 90 degrees that you've measured would be perpendicular to that circle, right?
It would.
Okay. Well, it seems like
here
we
comes
do
the
agree.
problem. No, hang on. Yeah. Oh, yeah. But no. Here comes the problem. If I then move away 111 kilometers and create a circle, and I measure the angle to Polaris from that circle using the horizontal or the vertical, doesn't matter really, I would have measured 1 degree change in elevation angle. If the horizontal at the first point would be parallel to the horizontal at my second point, 111 kilometers away, that would be more or less like a horizontal plane. Geometry tells us, but I'm measuring from this circle the angle to Polaris. The problem is geometry tells us that the angle does not, the change of the elevation angle does not in any way geometrically conforms to being on a horizontal plane. So either the height, the elevation of the Polaris has to change, or the surface has to be curved, which means the horizontal is different from the horizontal at the North Pole.
What about the problem? Could the problem be that you're imagining that you can measure a distance to a light in the sky by using an angle?
I don't have
measurement?
No. In this situation, no. In this situation, the distance to what you call light in the sky is irrelevant. It doesn't matter.
So you're saying like Nathan Oakley, right? Nathan Oakley does the same thing, but he says he just doesn't work out to the light in the sky. Pretty much like you're saying. You can't use these angle measurements to get a distance to a light in the sky.
We don't need the distance to the light in the sky.
You can't apply that.
Yeah. But here's the problem, Bev. If the Earth was so-called flat or a horizontal
Earth
plane,
isn't flat, mate. Or a horizontal plane.
I know. It's for you. It's a horizontal plane with the topography and tides and waves.
The Earth is just the land that we live on. For me.
What? I don't care what it is for you.
All I say
what
is
I'm
that
asking
all
you.
horizontals are
hang
parallel by logical deduction. That all horizontals are parallel to the plane of the horizon.
But it's the starting.
You can say that all horizontals are parallel.
Is the starting premise of your logical part regarding that? Is that correct?
What?
Do you have any evidence that any horizontal established on Earth are parallel to each other?
Yeah,
by measurements.
We've done a realizing Euclid test, to show that a straight line lies within a plane.
It does, but you just done that from one single point. Have you done it for 2, 3, 4 points and compare the horizontals to one another?
Yes. Yes, that's the whole idea of the realizing Euclid test. Yes.
Oh, you have. Fantastic. That means then by your measurements and claim, the Earth has to be a horizontal plane with
No, it doesn't.
topography,
No.
tides and waves.
No, it doesn't.
No?
No, it's definitely not. The Earth is definitely not flat. It's definitely not a In fact, the Realising Euclid Test didn't bring the Earth into it at all. It was just to prove that a straight line lies within a plane.
Then how can you say that all horizontals on Earth are?
Because that's a completely different argument. I call that one the argument. It's just that all horizontals are parallel to the plane of the horizon, and you can use parts of Euclid to show that if two lines are parallel to another line, then they will necessarily be parallel to each other. That's the way it works. That's how I can say the all horizontals are parallel. I've just got in it. Oh, shit, is the voice gone? Can you...
Basis of it has to be validated one way or the other, which obviously you haven't done.
The Realising Euclid Test. Did you just cut out then? I got it. My voice connected went red.
Yeah, I think maybe I didn't hear. If you were talking recently, I didn't hear you. But you said what I said. You said you did not take Earth into account while doing the Euclid test. Yes. You said you did not take the shape of the Earth into account.
No, we're not bothered about the shape of the Earth. That's for crazy people, flat earthers and the like. But
that is a problem, Beth.
Why is it?
How do you validate then? Establishing different horizontals, the distance between them, they're actually on Earth are parallel.
Shared straight line segments, mate. That's the way you do it.
It's not what I asked for.
Well, that's what we did for the Realising Euclid Test. The shared straight line segment. That's the geometric principles, right?
Yeah, but it doesn't tell us anything about the local horizontals on Earth, does it?
Yeah, we used a tool that establishes a horizontal plane of reference.
Yes. Yeah. And did you make two of these?
Yeah.
At distance and compare them to one another? Do you use like an auto level?
I'll say it again. Shared straight line segment. Yes. I just got to go
segments.
Take some breakfast. I'll be back in a second.
Yeah. How long? Yeah. And the segments how long were the segments? You still there? Hello?
He just said he'll be back in a minute.
That's okay. I've got to go anyway. So, but ask him to explain then how we measure.
You can ask him yourself.
Elevation.
You can ask him yourself.
Okay, then he has to.
Yeah, I'm not your messenger. I'm sure you're quite capable of asking him yourself.
Yeah, but I don't have much time, you see.
Oh, okay, but everyone else does to do your dirty work. Fine. You carry on being obsessed with the shape of the Earth. We'll carry on laughing at you.
No, I'm not actually shape of the Earth. This ties into the claim. This turns into the claim that all horizontals on Earth.
No, it doesn't. You're one of the weirdos that thinks that if you talk about horizontals being horizontal and stuff, that makes you a flat earther. You're one of those crazy fools.
No. I'm actually what I'm doing is tying into the claim that all horizontals on Earth are parallel to each other. And how do we validate that? We could do it in several ways. We could use, like Beth says, lights in the sky.
But it doesn't involve
in the measure of diverging.
does it?
Yeah, diverging verticals.
Is that?
If you want to mesh that in with people who say that the Earth is a topographical plane, and I've never heard that stated here amongst these people.
Well,
that is their view or a model even. So
I've wrote in a comment some time back.
Well, I haven't heard that. Maybe you need to listen to what he says he is doing and what he is actually saying, and don't bring an assumption that people are affixed to some model that you imagine. So that was all.
No, that's fine. That's fine.
I'm back. Sorry about that. The missus breakfast.
Yeah. No, but then how do we check if my horizontal is parallel to your horizontal in the UK?
Well, you can know that all horizontals are parallel, right? There's no tilt to a horizontal.
From a single, are two horizontals at two different positions parallel to each other?
Yes.
Based on
yes.
Yeah, okay. If you establish them by being perpendicular to the local vertical, will they still be parallel? On Earth, I mean.
Yeah, vertical and horizontal are always perpendicular, right?
Will two horizontals at distance on Earth, being perpendicular to the local vertical, be parallel to each other?
Yeah, you just get 2 points at an equal elevation and join them by a straight line. Right? That's
not what I asked.
That's a horizontal, right? You can have a perpendicular anywhere along it. Can't you?
That's not what I asked for.
Well, could you
try
show
this.
one
Let me try this
one that isn't? If you want us to say all horizontals or whatever, show us one that isn't, and in reality, because you obviously think that they don't. So in reality, show us horizontals that aren't.
My question was, if we establish a horizontal being perpendicular to the local vertical, and you do this with distances between the horizontals, and you compare them, will they be parallel to each other? And the second question is, how can we check if this is correct or not?
Have you done that? Have you tested that?
Wouldn't the proof be geometric, right? Or presumably the proof would be geometric, right?
Yeah, it will be geometric, yes, but what we will
and horizontal
use as a base is a plumb.
Are perpendicular. We can say that, right?
Well, we know that verticals on Earth are diverged by distance.
See, again, you say you know that. I don't know that. How do you know that?
Show us one. Show me one. Show me where that happened. In reality.
2004 Switzerland geodesic vertical measurements, where not only the verticals diverge, or the plumb diverge by Earth curve, but they also diverge due to what they call gravity anomalies, close to mountains, lakes, and so on. That affects
is that geometric?
Plumb. It is geometric, yes.
Okay. So where's the geometry to support that? If it's a geometric statement, can we see the geometry that supports that, please?
It's based on the geoid.
Based on what?
The geoid.
Not got a clue.
That's what you call it in English? Okay.
Geometry, I said.
No, it's an idealized shape of the Earth.
A what?
Which is
idealized.
Yeah. Well, I'm sorry, my English is not my first language. So sometimes it can be a bit difficult to explain.
Can you pause this?
But anyway, it doesn't.
Yeah, go
on. So when you had taken a little bit of a break there to attend to the missus, Emma was saying that Stefan was one of these weirdos who's obsessed about the shape of the Earth. He says, no, not at all. But then now he has to go to the shape of the Earth to explain a geometry for what he's talking about, diverging plumbs. That's not geometry. A geoid is not geometry. Does anybody know this? That a geoid is not geometry?
Well, they don't seem to think so. But Mr. Sparkles is in the chat here, and he says, you see, as long as these arguments are about logic and Euclidean / non-Euclidean geometry, they'll go on forever. Non-Euclidean geometry is not logic.
Absolutely not.
I don't know.
Nor is it a geometry.
He thinks that, yeah.
And by the way, you Bev, you explained to him this shared segment of straight line.
Yeah.
And he's just ignoring that. Because he is still asking question, how can you prove that horizontal in one location is parallel to horizontal in other location? And you explained him that you have between two different horizontals, you have shared straight line. It means that they have to be, in fact, the same, on the same plane. So, and of course, parallel everywhere. And he's just ignoring that.
Yeah, but he did. You're right, Paper. He ignored it for a large part, but he did ask Bev how or if that straight line segment was checked. If it was somehow checked, I assume optically, is what he meant. But again, a total lack of understanding or hand waving away the real geometry, which says that two straight lines cannot share a segment. So if you have two straight lines and they're on the same plane, do they not have to be the same straight line? If or right? I mean, two straight lines cannot share. I can't remember, Bev. You know it better than me, right? But why doesn't he understand that? That's straight from Euclid, no?
Well, yeah.
Am I wrong about that?
Talk about the geometric principles, right? It's the same. Mr. Sparkles is in the chat again saying, you know, that we'll forever be debating this. Well, we've never debated it. It's ridiculous to think that you could debate geometric principles. Is ridiculous. We're not actually debating anything here, Mr. Sparkles. We're just trying to have a conversation about people's understanding of different things. All we're after, like Emma was saying at the beginning, like to him, just show us a horizontal that isn't parallel to another horizontal, and we'll be fine. You know, we can then go forward, but it's not coming. Never has been coming, and it never will be coming, because there cannot be a horizontal that's not parallel to horizontal. And yeah, we'll just never get it. So there's no debate. We are just talking about the fundamentals of geometry here. And trying to find out what Stefan here is talking about. It gets a little bit more interesting than this. This is a bit... But yeah, you're right, Kevin. It's hard to tell what's going on.
Really matter, because if we are going to do this, we have to come up with some sort of methods.
Realising Euclid Tests, mate. If you want to know if a horizontal is a straight line, right? Yeah. I mean, it may sound ridiculous, right? But a horizontal is a straight line, right? From point to point.
Yes.
All points at an equal elevation.
From one point. Well, it depends on what kind of geometry you're in.
What do you mean?
If you're on a sphere or a circle or something like that,
No, a sphere.
you will have
both a sphere and a circle.
which,
both a sphere and a circle are Euclidean geometry, right?
Yeah. But
Okay,
if
so
you
the
establish
geometry won't change, then will it?
Yeah. No. And you have a tangent, and perpendicular to that tangent,
Well,
you would have a
that's
vertical.
Euclidean geometry. Yes, that is.
Yeah.
Geometry.
No problem. But what happens if you have two tangents on a sphere or on a circle at distance?
What happens?
Are those two tangents parallel?
Unless they're at the other end of the diameter.
Yeah.
Then they would be
both
perpendicular to the diameter, right?
Yeah.
Making them
that gives
both
us,
perpendicular to the same line. Now, can you imagine that diameter being horizontal?
The diameter being... Oh, you mean like a circle laying flat down?
No, like stood up, vertical, a circle in a vertical plane.
Yeah, well, yeah.
And then you have the diameter being horizontal, and then you could have both of those, what you call tangents, but I'd just say they're perpendicular.
Yeah, it doesn't matter.
Right.
It's just a play of words.
That diameter can have perpendiculars, even in the center too, right? One in the center and one at each end. Any distance measured as a straight line.
We were talking. No.
Those geometric principles could apply to that very straight line, couldn't it? In reality,
you would have two,
right?
You have two. Hang on. If we establish two or three or more tangents on this surface, on the circle or on the sphere, and the tangent would be what we would call horizontal on the circle or the sphere.
No. You'd have to have the diameter being horizontal.
It doesn't matter. It doesn't matter.
What do you mean it doesn't matter? Yeah, it does, because you can't have all of the tangents to a circle being horizontal unless the circle is entirely horizontal. Then all of the tangents to that circle would also be on the horizontal, wouldn't they? Geometrically.
Put a ball. Anyway. Yeah. Put a ball on the floor. You have the floor is the tangent to us. Yeah. The floor will be the tangent.
So let's say the floor's level, right?
Yeah. Okay. Of course. It's horizontal. Fair enough. But put the ball down. Well, the ball touches the floor. That will be the tangent. You agree?
Well, the ball's just on the floor, right? You can't just turn the floor into a tangent. But yeah, I understand the geometric principles of.
Yeah.
Right.
And the ceiling would have been, if you lift it straight up, would have been.
And as long as the ball isn't rolling, as long as the ball isn't rolling, you could say that the floor is horizontal.
So those two tangents will be parallel. Yes, we agree upon that. The floor and the ceiling will be approximate parallel.
Well, if you put another board on top of the ball, right, then you could say that would be parallel. That would be a tangent to the ball also, wouldn't it? Because the ceiling wouldn't be a tangent to the ball, would it? You'd have to say another tangent, and then they would be connected by the diameter.
Yes, they will.
So that diameter would be vertical, right?
The floor, but then the floor and the ceiling would be a tangent, which is parallel.
The ceiling wouldn't be a tangent to anything, would it? Yeah, I found this a little bit strange as well. Like, you put a ball on the floor, and then the floor can become a tangent to the ball, apparently, but somehow he's getting the ceiling to be a tangent too. I'm not too sure how that works. We're going to go through a few different reasoning skills from him to relate into a ball and making tangents.
Really, it might be very big ball.
It's a big ball, yeah. That is the option, right? But
very low ceiling.
Yeah. Yeah.
if you lift the ball straight up and you hold it against
if you just touch the
from
ball
where it
on the
was laying
ceiling,
on the
you
floor.
can touch the ball on the wall at the side, the window. You can touch the ball to
Hang
any
on, let me
plane
finish.
surface,
Let me finish.
right? Couldn't you?
Let me finish. So if we lift the ball then straight up and let it touch the ceiling will be a tangent, and the floor and the ceiling will be tangents which are parallel. Do you agree?
No, you can't. You can't state that. Because you could touch the ball on the wall and say that's a tangent.
Don't make
you wouldn't say that that's
okay. Let's do it. Okay, let's
touch your ball on it.
Let's leave the ball. Let's leave the ball on the floor. Let's keep the ball on the floor. I got a big sheet of something, and I put that on top of the ball. I make sure that this sheet of plywood or whatever is perfectly aligned with the floor. Then you would create a tangent line on top of the ball at the same time, which would be parallel to the floor. Do you agree?
Yeah. Like I said, the geometric principles just shows that they're tangent to the same diameter of the ball. So of course they would be parallel.
Yes, but here's the crutch then. If I put that ball in a corner and the ball touches the floor and two walls, then you have three different tangents which are not parallel to each other. This is a way that we could check if horizontals on Earth established by the local vertical will be parallel to each other. Don't you agree?
What, the walls won't be parallel?
No, but they will still be tangent to the ball. Which means if you put it in a corner, you have three tangents. You have the floor, you have both sides of the walls, the two different walls.
But not to the same.
If you equate this to the tangent being a horizontal established by the plumb, then we can use this to see if.
Well, you could call the diameter of that ball, once that ball's not rolling anywhere, right? You could say that diameter of the ball is vertical, right?
Diameter of the ball. It could be horizontal. It could be 45 degrees.
No.
It could be any direction
where
you want it to be.
Tangent. Look, you've already got a floor. Don't start switching it now. You've got a ball on the floor. You're calling the floor a tangent. Right?
Yes.
To the ball. Yeah. Right? I'm saying if the ball isn't moving or rolling or anything, then you can say that diameter of the ball that's touching the tangent, where it's 90 degrees, that would be vertical, right?
Yes, you could say that.
So therefore, the two parallels, the horizontals that are perpendicular to that vertical, right, they are parallel.
The top and the bottom will be parallel, yes. Yeah,
exactly.
But if
can you, like Emma said earlier, can
hang on,
show me somewhere where they won't be parallel?
That's not what I'm saying. If I put the ball into a corner of the room, so it touches the floor and the two walls.
There you go. Once again, asked him to show us somewhere where the horizontals won't be parallel, because he's the one that's stating it. Mr. Sparkles is in the chat again, also saying the same thing. It appears that, all intents and purposes, horizontals are all parallel to the plane of the horizon, which would make them all parallel to each other. And that goes anywhere. So you can go for a journey and travel for as long as you want, make any stop at any point, and all of the horizontals will be parallel to both the plane of the horizon and the last position where you had a horizontal, where you checked it. They'll all be parallel to each other all of the time. There will never be anywhere where they are not parallel to each other. show us where it would be. Like, show us the black swan for the statement, all horizontal are parallel. Dead easy. You can talk about it as much as you want, but until you show us all horizontals are parallel, logic stands.
You have 3 tangents. Those 3 tangents are not parallel to each other.
No, but the two tangents to the vertical diameter would be parallel.
3 tangents.
What, to the diameter? The one that's touching the floor?
Yeah.
There's 3 tangents.
Yeah.
What, to that diameter?
Yeah, you will have 3 tangents. Yeah, you will have one of the floor and one of each of the walls.
Right, and one at the top. Right, now those one at the top.
No. Now I was just talking about putting a ball into a corner.
Well, I did say that. Well, then, just put the ball in the corner of the room now. I mean, this is one of the weirdest geometric things you've ever heard, like a conversation. I think everybody knows that if you put a ball in the corner of a room, it's just a ball in the corner of a room.
I think that he is avoiding that because he realized, that if you have this ball on the floor and you put something on the top of the ball and it would be parallel, it means that these planes would be parallel, horizontal planes would be parallel, which is against their claim, because he said that these horizontal planes will diverge, and so they will be not parallel. But now we have 2 parallel planes. So that is weird, really.
Yeah, Blue Marbles put a picture in showing that not parallel. He said zeniths and horizontals not parallel. It appears that the verticals aren't perpendicular to horizontal as well. I mean, that's violating that, because everybody knows that vertical and horizontal are actually perpendicular, but Blue's got them not being. I don't know why he does that sort of thing, but yeah, as you can see, Blue Marble Science has drawn a picture showing that vertical and horizontal are not perpendicular. I don't know where the horizontal is in that picture either. It's really weird. Dead strange. Where is the horizontal? There's no horizontal in your picture.
And no vertical.
Yeah.
Because they are diverging.
So strange why Blue Marble would do something like that. Are you sure you're all right, Blue? Well, here we go. Would the walls, right, be perpendicular? Could you square that off? Would the walls be perpendicular?
The walls are perpendicular, yes. Okay. That's beside the point.
Now, are the walls perpendicular to the floor?
They are vertical on top of the floor, yes.
As well as being... so we've got... Not only do we have the tangents at either end of the diameter that's on the floor and the ceiling, right? They're parallel. And you can also say that the walls are perpendicular to both of those.
But what you forget there,
right?
Yeah. But no, hang on. What you forget then, Bab, is that where the ball touches the wall, the tangent moves in 360 degrees around. It's not just in one direction.
It's just the ball moves 360 degrees around, right?
No, not the ball. Not the ball. If I hold the ball against the wall,
dude, yes, we know that any point touching anywhere on the ball or the circle, if it's a straight line, will be a tangent. Geometric fucking principles, man.
Yeah.
Come on.
360 degrees from the all around a complete circle.
There's
around.
No more. You can't fit
tangent
any
point.
more degrees into that 360, can you? You can't manufacture.
No. But no.
There's no spherical excess.
I could
you
I could
can't
then
find
make
any spherical excess for that particular 360 degrees. That's the whole.
Sphericals actually we can measure spherical excess. Yes.
What, to a
As
circle?
we've done several times, but no, not the circle, but on a sphere. I know you deny spherical triangles exist. You deny Lagrange's, Girard's,
a triangle fits within a semicircle, right?
Hang on, no.
That's the whole principles of sine and cosine, tangent, right? The functions of those.
Let me ask. Yeah.
Apply
Since
to
I have
the
you here,
circle.
Bev, what does a mathematical theorem equates to?
What?
It's a mathematical theorem, mathematical proof.
It's a theorem of proof. Theorem's a theorem, right?
Equates to a proof in math.
It
in
equates
mathematics.
to a proof. Can you show me?
Yeah,
that
it's the
equation?
same as proof. A theorem in mathematics is the same as proof. So we have Girard's, Gauss-Bonnet,
like Pythagoras.
We got and we got the Lagrange's theorems of spherical excess and spherical triangles, but still you deny spherical triangles to be a fact. Why is that?
Because triangles only have 180 degrees. That's what I say.
No, they do not.
Well,
planar triangles do.
A triangle fits within a semicircle, right? And since the circle has 360 and the triangle fits within the semicircle, the triangle has 180. Now, you can't start adding degrees to that because that would mean your mathematical principles.
On a curved surface. On a curved surface, you can.
A triangle has straight lines, though. That's the principle. That's why it has 180
on the curved surface.
Degrees.
Yeah. But on a triangle on the surface. But you see, now you're back into denying mathematical theorems, mathematical proofs.
Well, I'm not denying Pythagoras or sine,
yes, you are,
cosine,
because you're trying to define. You're trying to define a way. You're trying to define away mathematical theorems by your understanding of geometry and maths. You've narrowed it down to just one single definition.
Who has?
And that's that. Yeah, that's not right.
What down to what? You're making claims again. Please state a bit more clearly. I say that a triangle has 180 degrees. Now, that is provable in mathematics, isn't it? Yes,
it is.
Okay. So for somebody to say triangles have either more or less than 180 degrees, then they would have to provide that proof, because that proof then would falsify the proof that triangles have 180 degrees, wouldn't it?
No, it's two different shapes.
What, a triangle?
What's your problem? Yeah, it's two. One is a planar triangle. The other one is a spherical or hyperbolic triangle.
Please define your understanding of triangle, because, like I said, a triangle to me has straight sides.
Yeah, but I don't care what a triangle to you is, because we have a mathematical theorem, a mathematical proof.
That might be why we're getting mistaken. We have mathematical proof. Purposes here.
We have mathematical proof that spherical triangles have more than 180 degrees internal angles, and we have mathematical proof for hyperbolic triangles have less than 180 degrees.
You're just using the technical use of the word.
It's called
it's just the meeting
a spherical or hyperbolic triangle. Why is who has given you the authority to decide what a triangle is and is not above?
Well, I did read it. Interesting.
He's making he's saying something about spherical and hyperbolical triangles, and But triangles, for example, Pythagoras, he didn't say anything about spherical triangles. His theorem is about normal triangles, just triangles. So why he is saying that? Because he was talking about Pythagorean theorem. So why he is talking about spherical triangles now? They have nothing to do with normal relationships within triangles. So what's going on with him?
Yeah, he's asking me who gave me the authority to speak about or to define triangles. Well, I say I'm using mathematics, you know.
Yeah, so it is on behalf of mathematics or history of mathematics or whatever. This is not your claim. He's saying that this is your claim. This is not your claim.
Yeah, Mr. Sparkles has put a spherical triangle drawn on a sphere has 3 straight lines on the surface of that sphere.
That's just not true.
It's not a straight line, is it?
You cannot draw a straight line.
Yeah.
On sphere. Surface of the sphere is curved and planar surface is not curved. You can draw straight line on the plane, but you cannot on curved surface. So it's just like sphere. So that's the difference between plane and spherical surface. It is different.
Yeah, Mr. Sparkle seems to think that, I don't know why people do like this. He seems to think that a triangle is a 3-sided equilateral. I don't know. That's really weird. There's different sorts of triangles, but they all have straight lines.
Yeah,
this
is planar figure.
Yeah.
Implicitly planar figure. So.
Yeah. It from Euclid, it's within the definitions of Euclid, book 1, if you want to check it up.
Yes, but but new definition has come along later on.
Has it? Did they put it in the foundations of mathematics, or did they forget about that?
No.
I mean, my book is I don't know whether we're actually going to get to hear this. The new definition that came in later on, a triangle. I'm not so sure how you do that. You can't go back. It's sort of, we call this stolen concept. You can't go back at a later date and get a new definition of triangle. Mathematics doesn't work like that, particularly within the foundations like we're looking at here. Pretty old book.
But if you go into Legrande's, Girard's, Gauss-Bonnet's theorems, you will find them.
Mm-hmm. Yeah, but they're talking about planes within.
Because of course, if you only look at Euclid and only that, and regard Euclid is the only valid math and
for
geometry.
The foundations of mathematics. That's the. There's nobody else that does the foundations of mathematics like Euclid. And since that's what we deal with, just the basics, the real simple basics, foundations.
But there are more than basics.
What about
the world is full of more than basics?
The straight line, right, is the principles, and then the triangle shows that to be true, right? With all of the things that can follow from the straight line.
Yeah, a straight line where? Rieman's geometry? There's a lot of geometry.
Straight line in reality, where a line shortest distance between 2 points.
It doesn't need to be the short in a gravitational field. Stronger is a straight line the shortest way.
No, we're talking about in reality, the shortest distance between.
That is reality.
That is reality.
But
in reality, then the shortest distance between 2 points is a straight line.
The shortest distance, yes, but sometimes it can be hard for us to understand. But in special circumstances, what we imagine is a straight line, being the shortest distance, doesn't need to be.
Well, you can't get
You
any
just,
shorter than
curvature
the
of
shortest
space-time.
distance between 2 points, can you?
Because there's curvature of space-time.
Yeah, but
So
still,
you see,
this is definitely not the foundations of mathematics. What Stefan's trying to play about with here.
Yes, he's bringing this Riemannian or whatever it is called, this pseudo space-time, and this is just nonsense, because it doesn't tell us anything about it. It doesn't nullify Euclidean 3D space. So I don't know what he's talking about and why he's talking about this. I don't understand what he's trying to prove with that, because he agreed that the shortest distance, I would say length, between 2 points is straight line. He agreed on that. So why he's talking about difficulties? Because now he is talking about some difficulties. I don't know why.
it's
The
not that
shortest
simple.
distance between 2 points can't get any shorter. You can't transverse that distance any
normally,
shorter
yes,
than the shortest distance, can you?
Yeah, in our everyday experience, yes, I agree.
Well, I can't even imagine a shorter than the shortest distance, because that sounds ridiculous. It's called the shortest distance because it literally is the shortest distance. You'd have to go to some fantasy place where you break your mind in order to go shorter than that.
Yeah,
surely.
I totally agree. It's really, really hard to wrap your head around it.
And that's
These are
the basics
geometry.
of mathematics, right, that we deal with. So he's admitted that it's really, really hard to wrap your head around these other geometries. Well, that's because there's only one, really. You can only have the shortest distance being one thing. Right? There is no other shorter distance. There's no different straight line. There's only the one, really.
Not only that, but in this so-called spherical geometry, they claim that this shortest distance is longer than shortest. So it is not the shortest, but they say it is.
There's a shorter than the shortest distance is what has been claimed.
If they claim that the great circle is straight line, so it is obviously longer than straight line. But they say that it is straight line.
Yeah, but they say it's shorter than the straight line on a plane. For some reason, I mean, Bob's done it. Stefan's about to do it as well. Shorter. It gets into ridiculous sort of places.
Yeah.
There's only one shortest distance and everybody knows what that is. It's a straight line. It's really simple. Yeah, basic. But basics in mathematics today also include spherical and hyperbolic geometry. You can't just leave that out. That's the basics. Where do people get taught that? Because I'm a certain age. Can you tell me where the basics are taught? That I did that at the university. Triangle having 180 degrees can be falsified. Yeah. I did at the university 50 years ago. 20. Yeah. The university. He said the basics are taught. At university, apparently. So it seems like a really weird place to teach people the basics to me.
Yeah, that would be high school. So
because a lot of people don't go there, right? So a lot of people don't learn the basics. That would be ridiculous.
Only in high school or university.
5 years ago.
Right, so you're of a certain age as well, then.
Pardon?
You're at a certain age as well, then. So you're saying the basics.
Oh yes, I am.
How come the basics are only taught at university? Like, what? Doesn't that seem the wrong way round? Shouldn't the basics be taught at the beginning, the foundations?
I think, yeah. Well, I'm not. The spherical and hyperbolic geometry is quite advanced, isn't it? I mean,
you said it was basics. It can't be advanced. Hey, now we're saying it's advanced, but it was the basics. Sounds like advanced simplicity, doesn't it?
Contradiction, of course. Yeah. Basics
advanced and basics, except advanced
within
simplicity. That's the straight line.
Within mathematics, it's basic.
Okay. So if we've got 2 points,
not for studying it or so.
Okay, so in reality,
it's a foundation. It's a basic.
In reality, Stefan,
it's a basic.
We've got 2 points.
It's a basic foundation.
Point A and point B, and
it's
we've
a
got
basic
the shortest
foundation
distance between the 2 points.
It's a basic foundation of spherical and hyperbolic geometry.
Okay, right. So in reality, Stefan, we've got 2 points, point A and point B. Now, the shortest distance between those 2 points in reality will be a straight line, right?
Yes, it will.
Okay, so now that's the basics that we're dealing with.
Yeah. Yes, but you could do that. Let's say on a circle, you can make 2 points.
You can just do two
and
points in reality.
Draw a straight line. Hang on. Draw a straight line from one point to the other through the circle. That would be the shortest distance.
Yeah.
The distance along the circumference of the circle will be longer. You agree?
Absolutely.
Between those 2 points.
Right. Okay.
Yeah. Yes.
Right. So
that
in reality,
what you might call
in reality,
yeah,
Stefan,
in reality, that's a fact.
Stefan,
that's a fact in the reality.
Please, Stefan. In reality, we've got 2 plumb bobs, right? A distance apart. Now we're going to measure an equal elevation on those plumb bobs. We're going to hang those plumb bobs from a bridge, and we're going to say, with the water, one body of water underneath us, and we're going to say these 2 points are an equal elevation above, an equal altitude above that water, right? So these 2 points on 2 plumb bobs, an equal altitude above the water, they're at an equal height, right? So we're going to put a straight line between those 2 points.
At each point.
Yeah, we're going to put a straight line. Point. We're going to put a straight line between those 2 points at an equal elevation.
Yep.
Right, now that line has no slope, no tilt. It's called a horizontal. In reality.
No, it doesn't have to be a horizontal, because then you have to make sure that the line going from one side to the other is perfectly perpendicular to the plumb.
It's just the shortest distance between those 2 points.
It's a shorter distance, yes. But as we know that verticals by plumb on Earth diverge by distance. So I guess I'll give you one example.
Again, he's done another we know. I don't know that. Oh, I know that horizontal and vertical are perpendicular.
But they know.
He says he knows, yeah. But he said we know. As far as I'm concerned, when anybody says that, they're including me. If they're having a conversation with us and they say we, I assume he means me and him. That's what I assume anyway when we're having a conversation about this sort of stuff. I don't like people saying that we know things, because I definitely know what I know. And I know what I don't know as well. That's the beauty of knowing what you do know. Whereas Stefan's trying to tell me that I know something I don't.
Yeah, I suppose you heard the argument about
that those 2 plumb lines. Are you saying that those 2 plumb lines won't be perpendicular to the shortest distance between the 2 points?
No. That's not what I'm saying. Right,
so he's not saying we've got 2 plumb bobs. and we've got 2 points marked at an equal elevation on those two, and we're having a straight line between the two. Stefan says he's not saying that, but he is actually saying it, because Blue Marble's done it as well. He showed us a picture earlier. He imagines that the vertical and the horizontal are not perpendicular. At least the horizontal, that's the straight line between the 2 points, the ones that I call horizontal with zero slope. That's what Stefan says. He imagines the verticals not being perpendicular to that. It'll take a bit for it to come around, but we will eventually get to this understanding. I'm hoping other people will start to realise it for themselves. I think people are starting to realise these sort of geometric concepts.
Saying is that the plumbs will not be parallel. They will diverge on Earth. That's a problem.
So that's
which
what
means
I said.
if
So
you
they
if
won't
you
be
measure if you have
to the shortest
hang on
distance between those 2 points,
hang on.
Stefan. What are you talking about?
Hang on.
You're talking out.
Hang on.
You're talking out of two sides of your mouth here at the same time.
No. If you then measure the distance between the bottom part of those plumbs and the distance between the top of those 2 plumbs,
where's the top?
That would be 2 different distances.
There you go. So he's saying that they would be diverging outwards, so they cannot be perpendicular to that line, which I would call a horizontal. But they are plumb bobs. That's fascinating to me, that people can actually think that. Don't know if anybody is following. It's hard to get to picture this in your head, but you've just got one line between 2 points at an equal elevation, and Stefan's saying that the plumb bobs won't be perpendicular to that line.
Bottom, it's towards the water, and let's say the top is 10 meters up, something like that. Doesn't matter really. The distance between the plumb lines close to the water will be shorter than the distance between the plumb lines 10 meters above.
Well, we said we just add the 2 points, right? We just add the 2 points, like let's say 5 meters, right, above the water. And we've marked 1A and 1B. Now we're saying the shortest distance between those 2 points will be a straight line. Yeah?
Yeah, if you establish,
Okay. So what I'm asking you is, do you not assume that that straight line will be perpendicular to the plumbs?
No.
Oh.
They will not.
Oh.
Because the verticals diverge by distance on Earth.
That's...
Rails in large towing tanks is an excellent example of that. Where you have like towing tanks like the BE600, which is almost 600 meters long, and the rails are at the exact same height above the surface of the water for the whole length. And the rails curve, and they curve exactly as expected on a spherical Earth.
Okay, cool.
So,
so it could be shown within 600 meters, could it?
Yes. Even the Boulderwood in the UK, where you live, the rails curve. Which means that the surface of the water then has to curve. Which means any plumb, let's say both sides of a pool like that, perpendicular to the surface of the water, they would be.
Have you ever heard of the Realising
Euclid
Tests?
Well, they will. I don't care about Euclid test. It's not for
so
me. It's not a test.
Excuse me. So earlier, you asked Bev, had he tested this in reality with like an auto level and what have you, and he said yes, that he had realised Euclid for himself, and it seemed important, obviously, that to you that he'd made tests himself. It wasn't just something he'd imagined or made up or read somewhere. And now, I mean, you said you'd university 50 years ago or whatever. In all your time, have you ever done this experiment yourself? to show,
Water level?
well, over 600 meters, it seems, that this is so that these perpendiculars diverge. Have you ever done that yourself? Have you tested it, or how could that be tested if you haven't?
Well, I've measured it like the angles
in this question. So that was you're saying a lot, but I wonder what you've done and whether you've tested any of this yourself.
I started off by explaining how I measure the elevation angle change by distance to Polaris.
Yeah, but you said you could do it. I mean, in reality, that's a long way away.
Yeah, but that
600 meters.
Yeah.
You said 600 meters, so you should be able to set that test up yourself, or even a little bit longer. In reality,
I see. So now we're back to you have to do it
40
yourself.
million light years. Well, that's what you asked Bev. You said it seemed to me that it sounded like that was important that he had actually done it and wasn't just imagining.
No. The reason why I don't care that much about his test is that he said he did not take Earth into account at all.
He tested what you needed to test. He's presented you with the same test, and you said that they diverge. So you should equally be able to go, nothing to do with the Earth, but you're going to test plumb bobs and verticals and perpendiculars and horizontals. It doesn't have to have anything to do with the Earth. It's just a test that you could do.
I have tested it by measuring elevation angles change to Polaris by distance, which is
millions of miles. You said, how could you possibly know that?
I don't care. It doesn't matter. Hang on.
From you.
I think no.
Physically.
Hang on. It doesn't matter. It doesn't matter when doing those measurements. The elevation of Polaris doesn't matter. It's irrelevant to the measurements. You have a point which you use as a reference, and you move away from it, and you measure the elevation angles as you move away, and that tells you either the elevation of this light in the sky, as you call it, has to change.
I'm just looking for something simple, a simpler thing than that, a simpler verification, because at some point I'm going to need to tell my daughter that the triangle isn't a triangle. I've got to tell her that and work out how to explain that the triangle isn't a triangle and how that changes. And how perpendicular isn't, how vertical isn't perpendicular, that kind of thing. Now, if you can do it over 600 meters, then you should be able to do that in a simple test. That's what I mean. Not looking, millions and millions of miles away or 1,100 kilometers away from where you are. How could you possibly verify that? I'm talking about something simple. Something simple thing in reality that we could do.
We have.
I'm just looking for something simple that I could do and try to understand that, just to understand what it is you're saying and verify that. Because I know that, what horizontals are and verticals and perpendiculars in reality.
But that's what I mean.
And that hasn't conformed to the story you're saying. So that's where I'm a bit lost.
But what you could do was the same as I did. You measure the angle to Polaris at different distances. It doesn't have to be 111 kilometers. It could be whatever you like. You just need to know the distance between the two observation points of 3 or whatever, and then just calculate the distances from there. And that would tell you something.
That's what the flat earthers are doing. Exactly what Nathan Oakley's been doing. We've been telling him you can't do
but the problem is, yes, you can. But the problem is,
you can. You said that
when you do this, hang on.
Are you saying you can measure a distance to a light in the sky now?
No, I said you.
You can definitely measure an angle.
The distance to the light in the sky is irrelevant in these.
That's what Nathan Oakley says. That's exactly what Nathan Oakley says. Exactly.
I don't care what Nathan Oakley says. I don't give a shit what that idiot says.
Right, well, you're saying the same thing as him. That's what we're saying.
No. I'm saying it's...
You said exactly the same.
The elevation of Polaris is irrelevant when you do these measurements.
That's exactly what Nathan Oakley says. Exactly what Nathan Oakley says.
Exactly.
Yeah, so what? But it doesn't matter what the elevation of Polaris is. The problem is, if the Earth was flat, as it is according to Nathan, as you measure these angles and distances in reality, to fit that on a flat Earth, the elevation of Polaris has to change as you move and make new observations. There is absolutely no chance on a flat Earth to have a linear change of elevation by distance.
Well, yeah, we
It's
say you
simple
can
as
do
that.
it. You can do fuck all with an angle. Look in the chat. With just an angle and no additional information, we cannot determine or conclude anything about geometric properties or relationships.
You have two angles. You have the 90 degrees at the GP. You have the elevation angle at the observer, and you have the distance from the GP to the observer. Two angles and one distance. What else do you need?
Which two angles do you have? You presumably need a triangle.
Yes. Remember, we were talking about you could be directly under a star.
That's what Nathan Oakley says too. Right, so the distance,
that's a fact.
Okay, so it's a straight line.
Sorry about that, but
right?
that's a fact.
Okay, you're imagining. You're imagining.
I'm not imagining anything. It's a fact.
Line from your position to the light in the sky, right?
Yeah, it's a 90
you're
degree
imagining
angle
a straight
from the
line
ground
for the other part of the angle that you're going to measure.
No,
you're measuring the angle from the light in the sky to the ground, right?
Yes, it's at some point
so
you have a star or a light in the sky.
That's one angle
in the sky.
Yep, that's one angle where you are,
and you move. Yes.
Right now, where's the other angle?
You don't need it. All you need is two angles. And
no, listen. It gets so convoluted, doesn't it?
Yes, and he doesn't realize that if he doesn't got this distance to the star, to the Polaris, he cannot establish this his precious GP of the star. He doesn't realize that if you don't have this distance to the star, you cannot establish, geometrically at least, position of this GP. You don't know where it is, how far it is.
That's exactly what Nathan Oakley and Brian's logic was saying the other day, though, right? You don't solve the thing for the distance to the light in the sky, which is exactly the same as what Stefan's saying. Stefan at this point is no different than Nathan Oakley or Brian's logic.
Yeah, but implication of that is that you don't know that GP of the star. You cannot know that. They don't understand, both Stefan Mood and Nathan Oakley and Brian's logic. If they haven't got this distance to the star, they cannot have this GP. Simple. So they cannot make triangle.
Yep. And then they say they don't work out the distance to the star, which is completing the triangle. It's very strange. Yeah. He wants to have two angles, but I don't see how they can have the 90 degree because they're not measuring it. They're just assuming it. I mean, it could be 2 foot in front of them. You never know.
Hang on. Let me
said
finish.
You've got two angles. I've said you've just got one angle that you've measured. One. Where's the other angle?
90, the GP of stars is
Where's
a fact.
that?
I mean, you can't refute this. Yeah, it has been done millions of times.
That?
Wherever the star is, and you at a specific time.
Right.
If you don't understand this, it's going to be hopeless.
So how do you have that distance where you place your 90? Where does that come from?
Well, it's quite simple. We know the GP of Polaris quite accurately. And we know the
What
distance
do you mean
from the
by
North
quite
Pole to
accurately?
equator.
What do you mean by quite accurately? You
Of
mean
the last
from what you've
the
told us
last
earlier, we
yeah.
know
You said it
that it's
wasn't there.
not at 90.
At the geographic and the North Pole. No, but just move
So it's
away
not at
accordingly, and
90.
you will be
Right. So we
you will be
know that we don't have a 90 there, right? That's one thing that we do know, right? That we don't.
Not above,
according to you.
Bav. Not. I find it fascinating. You still can't grasp this.
I'm trying to grasp it. I'm listening to your example.
But hang on. The 89.45 degrees.
So it's not to 90.
Polaris is off. Yes, but if you move to the side.
Well, if you move to the side while you're measuring an angle,
the distance you need to at some
point
you will be directly at some point you will be directly on the Polaris.
So you're going south to north.
It's not that many kilometers off the rotational or the North Pole. Pardon?
It's not, according to you, it's not at 90.
Above the rotational axis of Earth, no. But if you move a tiny bit aside,
if
the
you
distance
move
you need
a tiny bit to the side,
yes, from the geographical North Pole, then Polaris at some time will be directly over your head.
That's not where you are. You're measuring an angle, remember, to the light in the sky. You're not measuring a 90, are you?
No, we were talking about GPs of stars, didn't we?
I don't know. You were.
Wait.
So this is, I found this is very, you'll hear this a lot. We're talking about measuring an angle to a light in the sky with a sextant. And what Stefan's doing now is talking about another angle somewhere else where he isn't. So this is just in his imagination what he's doing here with this other angle. He's only measuring one angle from one position. He's not at this other position. And hence not geometry. You've just got one angle. And Stefan's trying to find it difficult how I'm not understanding that you can have this other angle as well. But that's a flat earth thing. This is what Brian's Logic and Nathan Oakley are doing. They're also measuring an angle and then putting a 90 degrees somewhere else where they are not. That's not what you do geometrically. Nobody can seem to follow through with the principles that they're talking about. Stefan and Nathan Oakley and Brian's Logic and all of that, but namely Nathan Oakley, seeing he got upset about us saying you can do fuck all with an angle. Nathan Oakley got the most upset about that, and Stefan Mudd here, I say, is defending Nathan Oakley by doing this very same thing.
Why do all celestial navigational manuals have the positions of stars at specific times? Hundreds of them. If you deny that you can be directly under a star at the specific time, then this is hopeless.
You've told
Polaris being like half a degree away from being
not
90 degrees above the geographical North Pole. Doesn't matter. You just move
90.
No, you just move aside accordingly. If it's half a degree, that should be about 55 kilometers. And at a specific time, as Polaris rotates around, it will be directly over your head. And then you know where the GP of the star is.
So why do the books,
at that point, you have 90 degrees, you have the elevation angle from the observer, and you have the known distance. You have the known distance from...
Could I finish, please? 10th man stuff as well, then? Like Nathan Oakley.
Could I finish? I haven't even started
like
yet on the argument.
Earther, mate.
If you know where
Let
90
me
degrees
finish,
is, he
and I'll
said.
tell you why it's not a flat Earth argument. Because
you just keep rambling
no,
on like Nathan Oakley. You're like Nathan Oakley without a mute button.
Okay, so now we have, okay, let's make this short. We have a 90-degree angle. We know the distance from the
You don't have a 90-degree angle. That's what you're imagining, isn't it?
Don't you understand
according to you,
that
you
if
don't
you move
even have a
55
90-degree
kilometers
across
south
a straight
of
line.
the North Pole, if you move about 55 kilometers away from the south, from the North Pole, at a specific time, as Polaris rotates around,
Stefan,
you will be directly under it.
Stefan, do you have 290 degrees at each end of that 600 meters?
What the hell are you talking about?
Do you have a 90 degree at each end of the 600 meters?
Don't run away from the GP and distance. So now you know that if you still don't understand how you can be directly under Polaris, I don't know why. But we can. You just move away about 55 kilometers from the North Pole going south.
What you're trying to say?
Because I can't finish because you're jumping all over.
600-meter line, right, from A to B.
Forget the 600-meter line, and then we move away
90 degrees at each end of that 600 meters.
Let me finish.
Stefan,
no, let me finish the Polaris.
Answer the question. You've got a straight line.
I will when I finish
from A to B. Right, so here we go. Stefan, I don't know whether he ever does, but he's measured an angle. Now that angle is the inclination of one straight line to another straight line. That's the angle that he's measured with a sextant or a theodolite or whatever. It doesn't really matter. Now, when he says he has a 90 degrees, is that 90 degrees being two straight lines once again? Is it related to either of the two straight lines that he's measured with his angle? Anyone?
Not on his model, but still pay attention, because when he's talking about some other stars that we can have GP to them, but then he's switching to Polaris, and nobody was there. So why he's talking about Polaris? GP of Polaris, to which we cannot go, and he's switching to other stars. So why he's making claim about that?
Because even point this out, paper, right? He measures an angle. Now that angle is one straight line inclination to another straight line. Then he's saying he has a 90. But the point I'm trying to get here across to Stefan Mudd is the 90 degrees is also two straight lines. Are either of those two straight lines of the 90 related in any way at all to the two straight lines that he's measured with his angle?
They cannot. On his model, it is impossible.
It's not on his model. Forget about his model. Just the 90. Is the 90 related in any way to the angle that he's got?
No.
No.
It is not.
Same for Nathan Oakley. There's no relation. Oh, hey up, Rob.
Sorry, I got a bad leg.
Yeah, it's a bad connection. No, Rob, we can't hear you. You're going to have to drop and come back again. That's a bad connection. It just sounds really muffled.
Yeah, I didn't understand any word.
Yeah. So yeah,
I'm not sure that was Rob.
What was it?
Stefan Mudd was in here and then he dropped out.
Oh. I thought that it was Rob.
Well, anyway, The 90 degree does not seem to be related.
It was me.
Way.
Sorry, I got my other headset on that's really bad.
Yeah, that's better.
But also, Stefan was in here, so maybe he wants to come back.
No problem. He can defend his claims. He is in the chat, YouTube chat, so he can join.
I'll be back.
He's typing in the thingy chat there. Yeah. Is the 90 degrees related to the angle that you've got in any way? That's the question to be asked. Oh.
No, it is not. Because they claim that they have no distance to the star, so and they say it is irrelevant, so they cannot have this 90 degree. From what?
Yeah, that's the difference between Nathan Oakley and Brian's logic and Stefan. I think the main difference. The two angles that Stefan has are not related in any way. At least in his own mind, I would imagine. He can't even draw a picture of how these two angles are related to each other.
I will when I finish with elevation
at each end.
Yeah. Are you running away from the Polaris now, huh? You're trying to deflecting and get to another subject.
You said you had two angles and one was at 90.
90 degrees, Stefan.
Bev, if you move away about 55 kilometers from the geographical North Pole and the Earth rotates, which means that the Polaris will rotate above your head, at a specific time, you will be directly underneath Polaris. Do you understand
this? Why is it not calculated to that then? Why are the calculations not directed by time to exactly where this 90 degrees is? Why is it 89.15 or something?
Yeah, well, it's very close to 90. So you can add in the tiny descriptions.
It makes a lot of difference. If you know that 55 kilometers away, you could be at 90. And that all relates to time, and you know where that could be. Why does the book that you're using, why does it not relate to that instead of this other not 90?
Well, it's half a degree and it's known, so it's very.
So it's not a 90. That's the point. It's not 90 degrees then.
No.
What you're measuring to.
It's what is it? It's about 15 degrees off, I think. The latest measurement.
So you have your
it's almost.
You have your angle for Polaris, whatever you said that was, and then you have this 89 and near enough 90. You said, which is 89 something. Those are the two angles.
Well, well, if you move away from the North Pole, the distance you need, you will end up being directly beneath Polaris at one time, and that should be about.
Well, but you said you won't. You said you won't. You don't have to go south to get to north.
Yeah, yes, a tiny bit.
Go south, go north. Really. Okay, that sounds sensible.
You have to go south from the. You have to go south from the rotational axis to be at 90 degrees below Polaris.
So you haven't done that. It's just still an imagined idea, isn't it? It's a concept.
Well, it doesn't. It doesn't really matter because a lot of people, hundreds of thousands, in fact, have made a lot of elevation angles to Polaris at different distances from different sides of the world. So you know. So even from that, you can just calculate where it is. So that's no problem.
It does sound a lot like Nathan Oakley and Brian's logic and the triangle that they said isn't a triangle.
No, yeah. But the point is, I haven't finished it yet because
to me.
Yeah, but here's the crux, and this is where Nathan misses it. Is if the Earth was flat, there's absolutely no way you can measure have a linear change of elevation angles by distance. It must be non-linear. Which means it does not conform to a flat Earth at all.
Yeah, the Earth's not flat, mate. We know that.
No, it's curved.
It's curves all over.
If you measure one, Yeah, a curve is a sphere. It's quite simple.
What is?
And just this simple measurement that anyone can do tells you it's a sphere. Because there's only two options there. Either the Earth is a sphere, or the elevation of Polaris has to change.
You can't measure the elevation of Polaris, you muppet.
Elevation, exactly. But if you were on a flat Earth,
says. You can't, you can't use geometry to apply 90 degrees that isn't even a 90 degrees somewhere in the distance. You can't imagine that. At least I can't. The thing is, you seem to be able to.
No, you can't, but I can.
Yeah, I know. It's got holes in it all over your thing. Even
no. Hang on. Yes, geometrically, I totally agree. Because the thing is, if the Earth was flat, you would end up having a right-angled triangle.
Yes,
you would have a 90.
It's not flat.
Exactly, that's my point. Because Nathan claims it is, but according to him, then we would end up
talking about your boyfriends. Then what are you doing? Are you obsessed? I suggest you go to Nathan and tell Nathan he can't do it, like we have.
I don't care about Nathan. The point here is
why you're coming here. You're coming here to try and justify Nathan Oakley's fucking ridiculousness about measuring an angle.
Why the hell do you lie? No, now you're lying, because what I'm telling you is that Nathan is completely wrong. Because if for his model
go and tell Nathan, don't come here and tell us. It's well
documented
that we've been to Nathan Oakley and told him he cannot do this. It's not possible to measure a distance to a light in the sky.
Yeah. The point is, Bav, that horizontal is always perpendicular to vertical. We agree on that.
Absolutely, yes.
Yes, and as we measure elevation angles to Polaris, the measurement tells us that the horizontal has to change by distance, which means horizontals on Earth's surface is not parallel to each other. Simple as that. That was the point. That was the whole point. Nathan's model does not work at all. Neither does the claim all horizontals on Earth are parallel to each other. So where does that leave us?
He describes the model you're describing. And as Bev said, in reality, he had tested Euclid, the Realising Euclid Tests for himself. And in reality, the conversations have been had with Nathan and his crew. So, that has been done. It's not an imagined thing or something that doesn't quite work. So, yeah, maybe you should go and challenge that, because you'll find it's a very similar, description that you're giving.
Yes, it just shows that the horizontals at different positions on Earth can't be parallel to each other. The geometry just doesn't work out.
What geometry?
That is the point of the whole thing.
What geometry?
Geometry, yes.
What geometry?
Okay. We have distances, we have two angles. And then we can calculate.
You don't. You only measure one angle. The other
one's imagined. You have two. You have no. Bev, in celestial navigation, this is a known fact. You have pages up and pages down of position, GP of stars and their position at specific times according to GMT. This has been done for hundreds of years, imagine. If you still maintain that we can't have a GP of a star.
I'm saying by measuring one angle, you cannot place a 90 at a distance from you. Yes, that's what I say.
We know where the GP is.
How?
We know the distance from the GP to the observer. And
how do you know where the GP is? How do you know that? Again, you've made another claim.
We could just go into
I don't
go into
know
nautical almanacs.
I don't.
Well, I don't care if you don't. Then you're just arguing from ignorance.
When you were using "we" in your terminology, and I'm just saying, I'm not part of that "we" that you're saying, right?
Okay, let's say quite a lot of people know about this. Sailors and a lot of other people who do celestial navigation, people who do astronomy,
but not
being professionals
geometers,
or
right?
amateurs.
Not geometers.
You fit this into geometry, that's no problem.
Well, a geometer would know that by measuring one angle, you can't presume to enclose the circle.
But you don't end up having you don't end up just having one angle. You have two. You have the 90 at the GP, you have the elevation angle at the observer, and you have the distance from the GP to the observer.
So you've got enough then to do your trigonometry then. That's like we say.
Yeah. Yes.
Well, why don't you?
And for the geometry, and for geometry to be linear, change of elevation angles by distance, the baseline or the it has to be curved.
Right. So rather than you saying you cannot do this geometrically, you're going to say you want to falsify geometry by measuring an angle.
No, I say you can. No. What you can do is compare the two models, a spherical Earth and a flat Earth.
No, this is exactly the problem that we have with Nathan Oakley, right? Exactly.
No, let me finish.
There's no difference. Stefan, let me finish.
No,
right?
hang on,
This is the problem we have with Nathan Oakley. We say that by measuring one angle, you cannot determine anything else geometrically from that. You say that you can.
Angles.
That is falsifying geometric principles.
Two angles and this length on one side, Bev.
Did you measure the other angle?
Which angle?
The
90?
You calculated the 90. Did you say?
I didn't no.
Where does the 90 come from?
Where do you think?
Out of your arse, right? You
from geometry. From geometry, from measuring elevation angles to Polaris. For several.
You have one angle.
We have several angles. This has been. We know that. Why is Polaris about half a degree away from the geographical North Pole? How do we know that?
I don't know. How do you know that? I don't know that.
You measure. No, you measure it.
How have you measured it?
The angle to Polaris at the North Pole? No, no. I need several people to do a measurement at the same time.
But you've just said you made a claim about we know something. Now I said I don't know that. So the question to you is, how do you include yourself in the we, or are you removing yourself from that group? Are you saying you can say we know something, but actually nobody in the room actually does know it? You're just assuming. It's just words.
Okay, I'm sorry. I'm sorry you don't know this. Okay, I'm sorry, but it's a fact. There's basically no discussion. We have people who's
right. We'll have to pause this in a minute. Can you see the picture I've just drawn for blue marble? It's an angle. And this goes for you as well, Stefan, if you're listening. There's an angle there. That's the angle that you measure with a sextant. Just place the 90 on that picture for us, will you? Where's the 90 that you imagine?
And by the way, he said that we know that the surface is curved. So, and he still has 90. You cannot have any angle to the curve, so it is impossible.
I want to see, because this is one of the things that we've said. Like, you can measure an angle, yes, definitely. There's the angle. You've measured it. You've got your sextant. You've measured an angle to the light in the sky. There you go. There's the angle. Now, where is the 90 that you assume? Where is it in the picture? Can somebody place it in the picture? Just draw it on. Where's the 90? Come on.
Without knowing distance to the star, you cannot place this 90 anywhere. So it's just pointless.
Yeah, there is no 90 there. You're right, Paige. Yes. We're after Blue Marble or Stefan or maybe Nathan Oakley. Let's see where Nathan Oakley. Anybody else? You've just measured an angle. Where are you going to put your 90 degrees? You can just copy that picture, draw your 90 on it and repost it for us again, please. Stefan say there is no GP of stars, no 90-degree 2 stars whatsoever. Oh, so there's no 90 there now, Stefan. Very contradictory. And Blue Marble says that it's your picture. It's just a drawing of an angle. I've not put any numbers there. And Blue Marble says that isn't how it works in the first place. Well, a sextant is definitely a thing for measuring an angle. And that's what we're talking about. We're talking about an angle. We're talking about, Stefan says he's got 2 angles. One of them's measured and the other one's a 90. Well, where's the 90 go? Where does it fit in the picture? Let us know, guys. Come on. Yeah, that's what I'm asking you, Stefan. I know there's no 90 in the picture because it's just an angle. With just an angle, you cannot determine any geometric properties or anything, right? So can you please place a 90 in that picture for us, where you imagine the 90 to be, Stefan? Please, anytime. You've got 2 angles, remember? You have the angle and a 90. Where's the 90? Simple.
You've been going to the North Pole and measure the angle as well.
Like
so that's why they
Stefan.
No, quite a few Norwegians.
You sound
to
like
the North
Nathan
Pole,
Oakley,
and
to be honest.
And
they go south to go north then.
Mm-hmm.
Did they confirm that they had to go south to find north?
They ski to the North Pole, and how they find the earliest ones, how they figured out they were very close to the geographical North Pole was measuring the angle.
How did they know that they were at the North Pole?
Measuring the angle to Polaris.
When it wasn't 90.
Does it have to be exactly 90? And you can still figure out where to be.
You keep saying it is. That's the other angle that you imagine that you have, isn't it?
Just a short distance from the geographical North Pole, you have the GP of Polaris.
If they measured 90, they weren't at the North Pole then?
No, but they knew that Polaris was a little bit off. So they compensated for
it. Without going there, they knew that beforehand.
Yes.
Wow.
They said, let's go to the North Pole. And somebody said, where's that?
It's not where you think it is.
You actually think people are that stupid.
Well, that's how people verified it. They couldn't verify it until they went there to verify it. You know.
What you do is
that's what you're doing. You're saying the same thing.
You continue going south until you're measuring an angle that's not 90. Is that right?
No, you go from the North Pole. Well, forget the North Pole. Just go north until you're directly under Polaris. That's very close to the North Pole.
Right, so you go north.
You forget the North Pole.
Yeah. So if you go north until you're 90, would you go past 90 to go south a bit to get to where you imagine the North Pole to be? But I mean, that's going beyond the point of this triangle of the 90 that we're trying to do. We're trying to finish the triangle, aren't we? From measuring an angle.
To get from the geographic North Pole to the GP of Polaris, you have to move south a bit. It can't be that hard to understand.
What, to get to the North Pole, you have to go south of north? Sounds really weird. That.
Well, so you don't understand the difference between the geographical North Pole, the rotational axis of Earth, and,
I don't
and the
understand
position
how
of Polaris.
you can make another angle. That's what I don't understand.
Could I go north?
You're only measuring one angle, and then you're assuming the other angle is 90 at a distance away from you, right? But it's not. It turns out it's not even a 90.
Could I go north until I ended up at the specific time be directly beneath Polaris?
I can go north, right?
I ask you,
I don't assume. Listen, wait a minute. I don't assume by going north at some point I will find myself going south. I don't assume that.
That was not my question. My question was, can we go north until we are directly under Polaris?
I don't believe that you can go north to go south. I don't believe that. But I know flat earthers do.
Polaris is south. The GP of Polaris is south of the geographical North Pole. So what are you on about?
Okay. So again, do you assume you can go north to go south?
What do you mean? If I cross the North Pole, the geographical North Pole, of course I will start to go south again.
Okay, flat Earth. That's what flat earthers believe, right?
Exactly that.
Yeah, but you could do that on the spherical Earth as well.
I'm just telling you, I don't. I don't assume I can go north to go south, because that sounds contradictory to me. It's just
you
not
can't
my
go
logic.
north of north.
You can't go south by going north.
Who the hell is talking about going? What? You can't go north of north. As soon as you pass the geographical North Pole, you start going south.
Yeah,
what are you on
exactly
about?
What I say. It just sounds ridiculous to me. That doesn't fit logically.
No, but that's not the point here.
That's the problem we have with flat earthers, right? Because flat earthers.
I don't care about those flat earthers. I don't care about them.
But you sound like them.
My point.
That's what we're saying.
My point.
You sound like a flat earther. You can say you don't care about them, but you sound exactly like a flat earther to me.
Well, let's start again. Let me ask you this: could we be directly on the Polaris at one point?
I don't know.
Okay, then it's hopeless. Then this discussion is basically overdone with, because
it's not really geometric, that is it? I mean, you better have better geometric principles than that.
You don't know that either, do you? You know, it's not like something you've done and you know it.
No, but you have. There's
when you describe it, you said it isn't there. It's somewhere else. It's south of north. So that even stranger imagination for something you don't know.
Oh, so we don't know where Polaris is?
I don't.
Claim?
I don't. You said you do, but you've never been there and haven't confirmed it. You just said that you believe it and imagine it.
Yeah, plenty of other people have confirmed it.
And we can people saying there's.
Just a matter of interest. Does anybody know where Polaris is?
I can only say that I can see where it is. So
it's in the sky, right?
Yeah.
Yeah.
Someplace in the sky. Yeah. So I can say that I know because I can see that.
Polaris is a light in the sky.
Yes, I can point out with my finger where Polaris is. Yeah, I can do that.
Yeah, there normally of a night time, daytime, not got a clue, can't see it to point at it. But yeah,
lots of things going on. You know, you don't believe everything everybody tells you, do you? That's that's on both sides of this model you keep talking about.
Well, we could use our different star. I could look up. I could just find one in a nautical almanac, which is.
You're still going to have a triangle that's just the same argument that the flat earthers are talking about with one angle.
Close
and
to where we
assume
are.
distance somehow. Only to find out that you are somewhere on the ocean, somewhere-ish. That's all that's for. Just to, you're just about here.
You can do it at land as well. That's no problem.
Yeah, well, you were talking about celestial navigation. But that's what it does, just to find out an approximate thing, doesn't it? Because nothing's definite about anything, by the sounds of it. But it was just, you don't know that it's, but, you don't know that if you went to where you think the North Pole is, that Polaris will be at your zenith and you'd be able to measure it and confirm it.
Really weird. I think you should go and have a word with Nathan Oakley, to be honest.
Yeah, we've tried. We've tried that too.
So can I'll just bring this back down here. Still no picture from Blue Marble or Stefan as to where the 90 is going to be placed on this angle. I mean, it's not hard, right? You've got two lines there. You've got an angle that's been measured. So where does the 90 degree go? Because Stefan was saying that he does have two angles. Nathan Oakley and Brian's Logic also managed to do it. Even QE says it's an entire triangle somehow. This is open to anybody. If you're a, flat earther, globe earther, and you can imagine that you do have a 90 degrees or the entire triangle, where would you place the 90? Particularly Stefan, though, seeing as what was going over here is with Stefan. Maybe Blue Marble might be able to help him out. Some of the Blue Marble scientists. It's not hard. It shouldn't be that hard anyway. Where do you place the 90? Where's that? Parallel light rays. That's Blue Marble, is it? Yeah, it is. Blue Marble science. Look at that.
Yes, and he's drawing this little star, and from that little star, light.
Neither of those lines are pointing towards it. What's going on, Blue?
Yeah, it's just, yeah.
Both of these lines, the one that you've got, and neither of them are pointing towards where the star is. Or is that just a picture? It's like no, it's not.
That's a picture. Yes,
that's a star. Hilarious. So that the right angle that you've got, the angle, isn't associated with that other angle in any way whatsoever, is it? None of those lines are associated with it at all. So what Blue Marble seems to be saying, I'm not too sure Stefan was saying that, is that you can measure an angle and then just place a 90 degrees somewhere else. Another two lines. They've got two separate angles there.
They would say on different horizontals. So this is not how it works.
No, he's not saying on two different horizontals. He's just saying that the 90 degree is not associated with the angle that he's measured in the first place. Is that Stefan? Can we get a confirmation from Stefan that that's what he's talking about? Because, if you were to, Blue, can you get the angle that I've done there and just sort of put where you'd put the 90 degree somewhere, just on the side? Just at some other random place, not associated with the angle at all.
Yeah, this is what Blue Marble science has drawn.
Yeah,
because this point where what he is writing that this is GP, it is not. It is on different tangent, so it on different lines. So this is not this line, this angle, because angle is supposedly between this line, which seems to be horizontal, and this skew line. So that would be measurement. So this GP is not related to this measurement. Absolutely. I don't know why he is drawing that kind of things.
It does seem a little bit weird. Stefan, is that Stefan Pot? Yeah, it doesn't seem like much of a triangle to me anyway. We'll see. All I can say is 10th man must be one hell of, or like, you know, he must have been one hell of a salesman when he was like, because he sold these people on this.
Was he as aggressive a salesman as Nathan, or did he have a different kind of approach?
Yeah, I don't know. I don't know whether he's his worker team. He tried to be persuasive, right? But when the niceness doesn't work if it's, you know, just false. He's been 10th man have been working on the sextant thing for years.
Right.
At least 2 years, because when QE and Nathan and all of those guys were around here, and they were dealing with the QE's fallacious modus tollens, the black swan. That's when 10th man had me and Brian's Logic have little private parties. Come into this Skype group. Let's have a meeting. And he was talking about his sextant thing, measuring angles, and I said that won't work. You can't do that.
You can.
Well, there you go. See, 10th man's a good salesman. I'd say you
No,
can't.
no.
Because you just got a one
course you
angle.
can.
You've got a sextant.
I mean,
You've got an
Beth,
angle measuring device. That's all you've got.
Yes, different. You can use quite a lot of different measuring devices. I mainly use my telescope. But anyway, as we said, we have a 90 degrees to the GP.
A telescope isn't an angle measuring device.
Of course you can. Depends on your telescope. You don't know? Okay.
Go on.
So you are talking just about one angle, but the fact is we have two angles and the length of one side. And plotting those measurements shows that the Earth is spherical, which means horizontals cannot be parallel. Oh, it's as simple as that. That's the whole point about the elevation angles to stars by distance. It's a linear change, which means it changes the same amount for the same distance.
Right, and where was that measured?
Oh, it's been measured hundreds of thousands of times.
Really? What?
Yes,
what measurement
really.
has been measured? The angle.
Distances and elevation angles.
So the distance.
Not just the
distances that have been measured. They're straight line distances, right?
No, they are distances along a curved surface.
But here we go again. Distances, as far as I know, are straight line distances. When you measure a distance, you measure a straight line distance. When you're talking
and
about a meter,
if you measure angle, you have straight lines.
Yeah.
And line of sight is straight line. So you cannot assume curve because it doesn't work. And you cannot have angle if you have this curved line. So it's just pointless.
Yeah, the
So
geometry
three
works
reasons.
with straight lines.
Yes, angle cannot work with straight line, with the curved lines, sorry. And angle measuring device is measuring in straight lines because line of sight is always straight line. So it's impossible to have to involve any curve into that.
But a distance measurement is a straight line distance, isn't it?
No, well, you could do it. You could convert from the distance along the surface to a straight line between the points. You could, but it doesn't help. The fact is that the elevation angles changes in a linear fashion, and the only way they can do that is if the horizontals change by distance.
Right,
That's
so the
why
horizontal
I wanted
distance,
to go.
that's a straight line, right?
No, for every point you make a new elevation angle. The geometry comes out when you plot the data. The geometry comes that the horizontal at each point must be different from the 1 degree per 111 kilometers will be the difference between the local horizontals where you measure the elevation angles from.
Is that the horizontal the observer's standing on?
The local horizontal, yes.
Oh. Nathan says that.
How
I don't know
long
what
is your
Nathan
local
says.
horizontal?
It's just it could be 10 centimeters, could be a meter, doesn't matter.
Doesn't matter.
Like
it's
a mile.
local horizontal.
6 miles?
No. Well, it doesn't matter because how long a horizontal do you think you need to make a measurement of an elevation angle? In fact, you don't. In fact, you could just go by the vertical, which is one single point.
How far was your distance from the observer to the GP?
Did he just say that you just can go off one single point? Not to measure an angle, you can't. You need 2 straight lines. The inclination of one of those straight lines to the other one, where they meet. It's very strange.
Well, I have to go back and look and see if I can find it. This is many years ago.
Oh, it's 111 kilometers or something like that, wasn't it?
No, but it's the distance, flying distance from southernmost point to the northern straight line across the surface of the Earth is 928 kilometers. I remember that much.
Sorry, that was a big distance. You say that's a horizontal distance?
No, I said it's a distance along the surface of Earth.
Yeah, horizontal distance?
No.
No.
Did I say that?
I don't know. I was just trying to work out what sort of a distance is it? A slope distance
along. Yeah, there's a distance along the surface of the Earth, the curved surface of the Earth.
Oh. A curved distance.
Yes.
See, when people hear distances, I'm pretty sure they hear of it being a straight line. Like, if you hear somebody says a meter, you imagine that's like a meter along a straight line, that distance, surely.
But you could always bend the meter if you have a piece of rope or something like that, which is 1 meter long. You can wrap it around.
It wouldn't be a meter
any shape,
distance,
any
would
shape,
it? The distance between the two
any
points.
shape you like, any shape you like.
Yeah, but you
That's
can't.
not what, you know.
Yeah, well, you can't say that like a ball, the diameter, the circumference of the ball to be a meter. I mean, you wouldn't say, look at that, look at that meter there.
You can't measure
It's a distance
a ball.
of a meter. You wouldn't say that, though, would you?
The circumference, of course, you can measure the circumference.
Yeah, but you
to be a
wouldn't
meter.
say the circumference of the circle is a distance of a meter, would you?
So what's the point? It doesn't matter, does it?
Well, that's what the point is, right? The point is that when people hear distance, they hear straight line distance, don't they?
I've repeated myself several times and said distance over the surface of Earth.
Yeah.
Curved surface
like
of
over
Earth,
the
yes.
hills and valleys and, up the... You mean that sort of distance?
No,
it's distance from A to B.
Do you say in English like as the crows fly?
Yeah, the shortest
Is that like
distance
an
between
expression?
2 points, yes.
Yeah, so let's say
That's
if
a
I
straight
fly
line,
from
isn't
my
it?
local... Yeah, yes, but it will, if I got in a plane, which I have done, flying from here to Tromsø, the plane will fly in quite a straight line, but it still will follow the curve of the Earth.
Isn't the long distance the adjacent in your triangle?
Yeah, well, the problem here is that when you plot out all these data that you
Straight line, then. Straight line, triangle. That one.
Across the surface.
That's sort of
along
adjacent.
the surface. Along a curved surface.
A straight line.
Yeah,
that's what I was trying to get at earlier. Your right angles that you assume 90 degrees perpendicular. Yeah?
Yeah, the local horizontal at the star's GP, yes.
Yeah.
See any problem with that?
Well, that would be tilting, wouldn't it?
No.
According to what you say, if it's not a straight line.
No. Every point on Earth has a different horizontal, perpendicular to vertical, to plumb.
Yeah, and all horizontals are parallel.
No, they're not.
Huh.
They can't be. They can't be, because if that was the case, if that was the case, the measurements by distance to a star like Polaris should come up in a non-linear
cannot measure
fashion.
a distance to a light in the sky.
It has nothing to do with the light in the sky, Bev.
You said the distance to Polaris. Is Polaris a light in the sky?
Distance from the GP. Oh, for fuck's sake, please. Now you're being dishonest. That's what I feel. You know the distance from the GP of Polaris to the observer. That's the length.
How do you know that?
That's the length of one side, because we have very accurate map.
You're only
We got
measuring
GPS
a fucking
and all the
angle.
work.
For fuck's sake.
And then you have the elevation
sound
angle
like
from the
Oakley.
observer to
You
Polaris.
sound more and more like Nathan Oakley.
No, you don't understand this. You deny. You
Yeah,
try
you
to
said you got two.
It ruins. It wrecks your claim that all horizontals are horizontal parallel. That's the problem.
You
here.
must have three
try to
angles.
avoid this fact as much as you can, because you know what the result
No, but you
was.
said you got two angles and the length of one side, so you must have three angles. This angle.
No. Two angles and the length of one side, no problem.
What?
Isn't it a triangle though?
Of course, it's a
Isn't
triangle.
It form a triangle. Two angles, the two sides you've got from the observer to Polaris and the one to the GP, and then it continues 90 degrees up to Polaris. You said.
Yeah, you can
so
complete a triangle, can't you, Nathan?
Yeah.
The GP.
Yeah, so that's what I mean. You've got three angles and the length of one side. You can solve for the rest of the triangle.
Yeah, you can.
Yeah, that's right, Nathan.
But the thing is, but the thing is, when you plot in the distances and the angles,
and not the distances.
The GP, the distances and the corresponding change of elevation angle, geometry forces you to end up with a curved surface. Otherwise,
what?
You will end up having a
Geometry
right angle
does-
triangle.
There we go.
So there is no triangle anymore.
He said geometry forces you to curve
No,
a line.
geometry.
I mean, that's how ridiculous is that?
Stefan Mood is just destroying his precious triangle.
Yeah, stolen concept there. Definitely. He's starting off with an angle, and then he's saying geometry forces you to curve one of the lines of the angle. Isn't that right? There's that blue marble done a... There you go. Check that out. That's not a triangle either, blue. So not a triangle. There's no triangle. Fantastic, blue. Well done. Stefan, are you okay with that too? Is that how it works? Go back and listen to that again.
Because we have very accurate
You're
map,
only
we got
measuring
GPS
a fucking
and all the
angle.
work.
For fuck's sake.
And then you have the elevation
sound like
angle
Nathan
from the
Oakley.
observer to
You sound more
Polaris.
and more like Nathan Oakley.
Because we have very
You're
accurate map,
only
we got
measuring a
GPS
fucking
and all the work.
angle. For fuck's sake.
And then you have the elevation
You sound
angle
like
from
Nathan
the
Oakley.
observer to
You sound
Polaris.
more and more like Nathan Oakley.
No, you don't understand this. Or you deny you
Yeah,
try
you
to
said you got two.
It ruins, it wrecks your claim that all horizontals are horizontal parallel. That's the problem.
You
here,
must have three
try to
angles.
avoid this fact as much as you can because you know what the
No,
result
but you
was.
said you got two angles and the length of one side, so you must have three angles. This angle.
No. Two angles and the length of one side, no problem.
What?
Isn't it a triangle though?
Two angles and the length of one side.
Of course, it's a
Isn't it
triangle.
form a triangle. Two angles, the two sides you've got from the observer to Polaris and the one to the GP, and then it continues 90 degrees up to Polaris, you said?
Yeah, you can
So that's
complete a
triangle.
triangle, can't you, Nathan?
Yeah.
The GP.
Yeah, so
the
that's
GP,
what I mean. You've got three angles and the length of one side. You can solve for the rest of the triangle.
Yeah, you can.
Yeah, that's right, Nathan.
But the thing is, but the thing is, when you plot in the distances and the angles
and not the
from
distances.
the GP, the distances and the corresponding change of elevation angle, geometry forces you to end up with a curved surface. Otherwise,
what? Geometry forces you to end up with a curved surface. The geometry does no such thing.
Geometry has no force.
Mm-hmm. But that's what Stefan said. What?
You will end up having
Geometry
a right angle
does
triangle.
no such thing, Stefan. Does
That's
no
good stuff.
Can't have a curved triangle, can you?
thing.
You don't understand it, then.
Yeah, well, we
Basically,
do.
you don't understand the geometry. Oh God.
I'm trying to understand what you're saying and trying to piece it together from the image you're painting. It doesn't seem to.
There's no
make
way that
sense.
geometry forces me to curve a straight line. It just doesn't happen. There's no such thing. There's no geometric principle, Stefan. No.
It does, Bev, to have a linear change of elevation angle by distance.
Where does it say that in celestial navigation? Bend one of the sides of the triangle.
When what you have to do is either If it's flat Earth, then you can calculate
The Earth's not
then you
flat,
will end up
Stefan.
with
No,
a
they don't do that.
triangle.
They give you a
You know that.
sextant. You give you a sextant, you measure an angle. They don't talk about the shape of the Earth. They just give you a sextant and you measure an angle.
Yep.
No, it's got nothing to do with shape. And then how does that triangle, how does that triangle become curved? Does it say so somewhere that you should curve one side of the triangle?
Not in celestial, but what you can do is you have the elevation angle.
Stick to that 600 meters, Stefan. Oh, yeah, I would.
And
that's what I was asking. Something we could actually get hold of.
Yeah.
We can go down the road and do it. We haven't got to look at millions of miles away and somewhere that isn't there. You said 90 degrees, but it isn't 90 degrees unless you go south of north and all that. Because that's why I asked in the beginning. You said 600 meters it could be seen. So that's what I was talking about, realizing your test for yourself in an environment that was within reality that you could actually do yourself and we could replicate and go, okay, that's what he means. Okay, we found it too.
Yeah, but if as we were talking about Polaris, if you do measurements and you plot it out, there's only two options. Either the light in the sky, as you call it, have to change elevation.
Wait a minute. Can you go with, you can do fuck all with an angle? Like, is that an option?
Or the baseline that has to curve.
No, you can just say you cannot do that by measuring an angle. Can't you?
Two angles and the distance, Beth.
No.
Two angles and the distance.
Only measure an angle. The rest is imagined. All of it.
You know, yeah,
and you can't assume that geometry tells you that straight lines must curve from measuring an angle.
You have two angles. You got 190. You got the elevation angle from the observer.
Where do they get the 90 from? Just measure at an angle. As you've seen, Blue Marble doesn't even associate the 90 degrees with the original angle.
Yes, because they cannot. So it is just gibberish. Stefan Moody is insisting on curving line, but it is not even spherical triangle, because spherical triangle supposedly has all sides curved. But in this strange triangle, we have only one line being curved. The rest of that is straight. So it is just not a triangle at all. Not even spherical triangle. Nothing.
Yeah, it's sort of a weird imagined thing that certain people have imagined. I can't help that. But I mean, like what they're talking about here is definitely, like you say, it's not a triangle. They're associating two angles, but they're not associated together. So, yeah, fantastic. Fantasy sort of geometry, what we're dealing with here. And this is why we said to Ruhif quite a long time ago, you can do fuck all with an angle. You can't even assume there's a 90 somewhere else. I mean, you can measure an angle. Fair enough, we'll give you that. But it seems like what they're saying is that you can assume that there's a 90 degree somewhere else from measuring that angle. Really weird. Definitely not geometric, what they're doing. But, hey, that's where we're at. This is the arena we're in. You have a 90. You don't have a 90, right?
Of course you do.
How?
It's just you denying the fact that like nautical almanacs and stuff like that.
That's a
even
book.
Today,
does that book have a 90 for you?
It does.
Okay.
It tells you a lot of different stars and their GP at a specific time.
Did you ever do the trig for that triangle you imagine?
Yes.
So how far away is the lightning sky? You know, the actual altitude of it.
Polaris. It depends on which model you use. If you use a flat Earth model, should be what?
How many,
Yeah,
how many
that's
different
flat
models of
number one.
trig are there?
It's at 45 degrees. That's 5,000 kilometers from the North Pole for the GP. And if it's
And
a
that's
flat
the
Earth,
altitude of Polaris, then, is it not?
no, but if it's a flat Earth, then the elevation of Polaris would be 5,000 kilometers.
No, it's
But as
not
you
about
move
flat
away,
Earth
get
or
closer,
anything. This
and
is
do the
just
same.
about a triangle, you imagine.
I said in a flat Earth model.
Triangles have nothing to do with the model of the Earth. It's just a triangle, geometric.
Yes, it does.
What's that in miles? So what's that kilometers in miles? Is that 2,700? Is that what it is?
Divide by 1.608.
Yeah, if you know the distance from the North Pole to the equator, you just half it.
Yeah, but the distance from the observer to the GP with a 45-degree angle. I've heard it in miles, but not in kilometers. I was just trying to confirm whether it was the same as what I'd heard in miles.
Well, it's from the North Pole to the equator is 10,000 kilometers. So halfway is 5,000 kilometers. So if there was a flat surface, then we could use the distance from the GP and the angle, and then yeah.
Well, I've heard 2,700 miles with a 45-degree angle. That's what but you said kilometers. That was all I was just wondering, whether it was the same as I'd heard before.
Yeah.
Because that's what Nathan told me. That's what Brian's logic told me. Exactly that. Exactly what you're saying.
Yeah. The problem for them is that if you move closer or further away and make a new elevation angle measured in reality, and you add on and you use the new distance, the elevation of Polaris must change. That's why the
what if you waited like 5-10 minutes? You'd have to change their
For fuck's sake.
No, I was talking about Nathan's flat Earth model, not the others.
Yeah,
but the thing
you've
is,
still got a triangle. Whoever it is talking, you've still got a triangle.
Yes, you do. But the thing is,
with two angles and the length of one side. In fact, three angles and the length of one side if you have two. So it should be solvable in any model, any paradigm at all. That's the thing.
So if you have the 90 and you have the distance, and then you plot out the angles measured in reality, the base curve baseline has to curve to have the exact same distance on the ground between every single angle.
So you don't have a triangle.
Does it say that? Yeah. Where does it say in the Celestial Navigation Manual to assume that the adjacent is curved?
That's an oxymoron. There's no such thing.
I was just talking about geometry.
Yeah, but
there's no such thing as a curved side to a triangle. Triangles have
I think I don't know enough. I'll leave you to the geometers because I don't obviously understand this at all.
It's quite simple. If you use the data that you have and try to plot it out, that you only have two options. Either
either triangle or not a triangle.
Yeah, let's just start with the triangle, a standard basic right angle triangle. And as you move along, and as you move along and measure elevation angles, for every 111 kilometers, you get 1 degree in change of the elevation angle. That is not possible.
Still, triangles have straight sides.
Yeah, that's not possible in a right angle triangle, is it?
So you don't have a triangle now.
No. I said let's start with the basic right angle triangle, and let's use the distance from the North Pole and the corresponding elevation angles measured. If you move along with this straight line, the position, the elevation of Polaris has to change as you go along, or the baseline has to curve to have a linear change of elevation angles by distance. There's no other way.
So either you don't have a triangle, or the imaginary right angle is imaginary, and that's why it doesn't work.
Well, we know we have a 90 degree at the GP. We know the distance, and we know the elevation.
We don't know that. Like, what are you talking about?
I don't give a shit about what you know or don't know.
Well, you
most
keep
of the rest of the
involving
world
me
know.
whenever I hear we. I'm part of that, right? Or you know,
us who has studied it a bit and done a bit of astronomy and things like that.
Okay.
We know it's like that.
You can't falsify geometry through astronomy, though, right?
Exactly.
Definitely not through measuring an angle, because an angle obviously is geometric, so that would be a stolen concept fallacy to imagine you can do that.
No, but you're absolutely right, Bev. We cannot falsify geometry. That's a very good point.
So then we can go with, you can do fuck all with an angle then, right? That's a geometric
two angles
statement.
and the distance.
Just one angle.
2 angles and the distance. Why do you keep going back to one angle, one angle? We have 2 angles and the distance from the GP.
Not with a sextant, you only have one angle.
I don't care about the celestial navigation just now. I'm just doing some geometry. We know the distance from the North Pole to the equator.
Do we know that? I don't.
You don't know the distance from the North Pole to the equator?
No, I do not know it.
Okay.
Do you?
To be honest, I can't be bothered anymore.
Can you tell me how you know it?
You don't know that. And it's just an excuse to get away from all the problems, geometry and
talking about
measurements
knowing
in reality.
Knowledge. Stefan. How do you
in
know
reality
it?
does to your model? So I'm sorry about I just can't be. You lights in the sky. We don't know the distance from the North Pole to the equator. We don't know shit.
Well, can you explain how you know it? Can you explain how you know the distance?
I can't be bothered. If you're so ignorant about how this is done over the years, I'm sorry, I can't be bothered anymore. And this is one of the reasons and that's just one of the reasons it's taken me such a long time to even bother to get into this Discord, because there's so much denial and
you have to back your claims.
And I don't know that.
That sucks.
So,
having to
I'm
back
sorry,
your
boys.
claims.
Yeah, no, but you can continue living in your strange world and let the rest of the world
You
go
can
on.
just explain how you imagine that you know this distance. That'd be nice.
No, I can't be bothered. You look it up yourself.
Oh, okay.
Try to gain some
you
knowledge
on your own.
and don't ask me.
Sounds like Nathan Oakley again. Are you all right, Nathan? You're getting good at doing voices.
Yeah. Lights in the sky. It's just so fucking laughable. I can't be bothered anymore. Lights in the sky. Do you know what electromagnetic spectrum is, Bev? Do you know how we can measure?
What's that got to do with an angle, Stefan?
Yeah, where is the geometry of the electromagnetic spectrum?
Sextants don't measure that, do they?
No, what it's got to do with it, you claiming stars are just a light in the sky.
Yeah, I'm claiming you just measure one angle, Stefan.
So you boys have a good time and enjoy your strange kind of way of looking at the world. And
no, it's great. It's great you came. I mean, it's great to hear you, and to have a conversation. That's what it's about.
Yeah. I mean, but it's impossible to have a conversation when I don't know this, I don't know that.
But really, you're saying that's what it is. That's all. It's just a question about what you do know and what could be verified. Because at some point, for instance, I'd have to tell my daughter that isn't so. Triangle isn't a triangle at this point, or whatever. That's important, really.
Yeah.
Try and understand.
Just tell her the different types of triangles. It's as simple as that.
Yeah, but I thought you knew. That's why. To ask how you know that's the question, isn't it?
How I know different types of triangles.
How you know that a triangle has more than 180 degrees and having one that isn't will falsify that a triangle does have 180 degrees, or where Polaris is, or those kind of questions. That's all. It's just just an inquiry. It's not It's not a battle, really. Just an inquiry about what is known and what's not known. That's all.
Yeah, it's like then you can read up on Legendre, Girard's, Gauss-Bonnet theorems, or other theorems regarding spherical and hyperbolic geometry.
Yeah, but you can't beat somebody coming and talking about it, really, and from their experience and what they know and sharing that kind of stuff. That's always valuable.
Yeah, and you can read up on it and
Distance
study
is
how
Euclidean, though.
Yeah. I mean, and there's a lot of stuff that one needs to wrap one's head around to understand how things work. The less you know, the easier it is to deny and end up with wrong conclusions.
You're in a prime position here to expand our knowledge by sharing how we can know the distance to the GP of Polaris. That's all we're asking.
Well, the measurement, we know the distance from the North Pole to the equator.
How?
Yeah, but several. I mean, it's all from using the lights in the sky to measurements over land. Simple thing like fiber optic cables from the northern Norway to Svalbard. I mean, and you know the distance between them and so on. You can go further north. There's a lot of the submarines which has been traveled under the Arctic ice using sonars and stuff. There's plenty of different measurements confirming the distance from the North Pole to the equator. And today with GPS as well, a VLBI, very long-based radio interferometry, tells us a hell of a lot about the shape and the movement of the Earth. There is so much.
So can you show us any direct measurements done from the equator to the North Pole?
You mean like stretching a string from the North Pole and up?
An actual direct measurement, however you imagine that.
Well, we know the distances across land from the equator to way up north. So we got most of the distance, and then it's not that very far from Svalbard or the north tip of Greenland to the North Pole. I mean, those distances has been measured in many ways. So I can't see.
Straight line distances, right? Straight lines.
Pardon?
Straight line distances.
Oh, across land.
Yeah.
So yes, the distances are known.
Straight line distances.
Distances across the curved surface.
No, the straight line distances across the
line. Yeah. And from that, of course, you could draw measure it, have a straight line across the curved surface from the equator to the North Pole.
Did you say straight line across a curved surface? Did you not realize the contradiction, the oxymoron you just spoke?
I do, but if you look at from the top down, it looks like a straight line. Okay.
I think he means a horizontal line that cuts through the hills and the valleys, right?
Oh no.
No.
No. That's not how you measure distances of the surface of the Earth.
Here we go again. They really have a problem with straight lines, and when you're talking about geometry and dealing with this straight lines, then I'm not too sure they understand that. You've got an angle, you've measured an angle, and that uses straight lines. They seem to want to refute the straight line. For some reason, I can't imagine why.
It's weird.
Yeah, because you're not measuring the short. You're not measuring the shortest distance from the equator to the North Pole. What you do, you measure the distance over the surface of the Earth.
Yeah, and you said that's not the shortest distance, but have you ever done orienteering?
Yes.
And you use two scale maps, right? Where the measurements are actually done in reality. To scale, like 1-to-1 done in reality, scaled down to fit on a piece of paper.
Yeah, I know. I spent some years.
Yeah, those are
in
horizontal
the army.
distance.
I spent some time in the army as an intelligence officer in a recon unit, and we used very detailed maps. So yes, I know.
Yeah, those are horizontal distances, and those contour lines you see on those very same maps, those are, you know, this on the same horizontal.
On a map, yes.
Yes,
but
exactly.
the
Scale maps measured in reality. Those are the shortest
Yeah.
distances from A to B, measured and plotted on the maps. Measured
Are
on
you
land.
sure about that? It depends on what kind of type of maps you're using.
To scale maps.
Yeah, most maps are to scale, but some has just squares. Some has different
Euclidean
grid
straight lines.
systems. Yeah, and different grid systems as well. So, but anyway, I have to go, boys. Sorry.
Oh, that's too bad.
Yeah. It's been nice talking to you. So I might be back sometime. Who knows?
Cool. It's Model Affliction Monday tonight. Go and have a word with Nathan as well. He needs a bit of help. 2:00.
I can't. I just can't stand Nathan. He's a fucking idiot.
Well, you go and tell him. Go and tell him that he can't do the things that he's imagining to do. But it's the same as what you're doing. Just for your information.
No. I've mentioned it to him in the comments quite a few times, but you know what he's like. So
yeah, you'll have to go in and tell him, because people don't know. He's gaining a lot of people. He's fooling a lot of people.
He does need to hear. He does need. People do need to hear people questioning that and different points of view. So, you know, it would be good if you could just, you know, speak to what you know and see how that compares or not. You know, it'd be good for people to hear. That's the thing. That's what I meant about you coming over and hearing your voice rather than reading you in the text somewhere. You can kind of put a bit more reality to it, and that's what's nice. You know, so that's what I mean. It was nice for you to come, and it'd certainly be good to hear you talking to Nathan about it. You know, and see whether your ideas differ with his or not, really, because they sound very similar. That's all, you know. So, he doesn't read his chat very often, and his mods, you know, kick people out if they don't keep to the narrative. So, yeah, I look forward to hearing you talk to him. That would be brilliant.
Yeah, his and my take on this is completely different. He thinks the Earth is flat, and all measurements shows that it's not. So.
He's imagining the same triangle as you, though. That's the only difference.
You
imagine that the geometry. You imagine that the geometry tells you that the straight line curves, and he imagines he can. He imagines he can make an entire triangle. Measuring an angle. That's the only difference.
Hang on. Let me finish off. Make a straight line, and for every centimeters, change the angle for a line by the same amount, and see if they are parallel or they diverge or converge.
See if what are parallel.
That would tell you the line.
All of the perpendiculars
if you have a straight line
to a straight line.
If you have a straight baseline, okay, and let's say every 5 centimeters, you start off with creating an angle of, let's say, 10 degrees. Then you go another 5 centimeters along the line, and you add another 10 degrees to it, and continue on and see if it hits the same point.
See if what hits the
parallel lines. Parallel lines do not converge. That's the definition.
Yes. So as you move along that line to hit the same point, the light in the sky, the angles has to change by distance, but in reality they don't. So it's just a simple example of how this works. But sorry, I have to go. Dog is shouting.
Are you not part of a paracosm where the angle changes by a degree per x distance? Is that not part of your paracosm?
Well, it does in reality. We know that.
You
1 degree per
literally
half
just
over
said
100
that
kilometers.
it doesn't do that. You literally said it doesn't happen. But, you're just contradicting yourself. It's hard to follow you. That's all.
Not if you have a straight baseline that you do the angles from. It won't. If you have a curved one, you can get it. Bye bye, boys.
All right, see you later. Thanks for popping in. 2 hours, 11 minutes.
You know, I didn't mean to butt in, but I had to.
Yeah. Well, I don't know. Like, they get like Nathan Oakley. There's a point that you can't get beyond because they're fantasizing shit. They come with just an angle, but like they've absolutely, like Betty, absolutely, that they think there's a 90 somewhere where they're not, that they can use.
Yeah, and then once they curve the straight line, not only did they, explode the logic, but they also lost the right angle at the same time.
Yeah.
They don't see that, of course.
Yeah, that's why the A to B. He doesn't have a perpendicular at A or B.
He didn't manage to link the fact that the maps are actually done like that in reality. A to B, shortest distance, plotted right on the map. He agreed with it, but he couldn't make the link from that to what he was talking about.
Wow. Hey, that's it. The end.
Can I say something now?
Yeah. Please do. Yeah.
So, were you calling him Nathan Oakley and he just was ignoring it, or what happened there?
Yeah.
Was it like you just kept calling him Nathan?
Because
he just kept going with it, or
he
something?
was imagining that he could do things with an angle that Nathan Oakley does as well. They look. He never came up with any sort of diagram or anything. Blue Marble did for him, but
I kept laughing at when you were calling him Nathan, and he just kept going.
The right angle that they have doesn't and isn't associated with the angle that they measure at all.
They like to pretend it's a right angle.
Yeah, Nathan does the same thing.
Yep. Would that be called imaginometry, like you used to call it?
Yeah, still going. Imaginometry's still the thing.
That's the only geometry with definitions other than Euclid.
Axioms, he's got a lot. Still there, still on the website. I think it's probably one of my best works. One of. There's many others. Plenty more to come too.
Thanks, Beth.
But when this comes down to it, right, there is one measured angle. You have a sextant. Sextant is the angle measuring device. From that, well, I mean, that's up to you. What do you imagine happens once you've measured the angle? It's not geometric, though. That's the point about this. Everything that gets done after measuring the angle is not a geometric. They like to assume it is, but it just simply isn't.
The funny part is in that what Stefan Mood was talking about, that he was building this this triangle for like over 1 hour, and he destroyed that triangle with his curved adjacent. So it is just sad for me.
Yeah, they like to assume that radials are verticals and tangents are horizontals. They're not. But I mean, it works within the narrative of this arena. I think you've got the flat earthers that allow the globers to have that sort of thing, and the globers allow the flat earthers, like Stefan. See, he's not going to go and have a word with Nathan Oakley and say that Nathan can't make the triangle, because that would expose them not having a triangle either. It's like a stalemate, if you will, where they just agree to not talk to each other about it. And that's why Nathan Oakley's upset at us, and that's why Stefan's coming round here and having a go at us, because we just say it doesn't follow any geometric principles at all. None of this does. From the flat earthers or the globe earthers, they're just a false dichotomy, where they just imagine they can make up their own type of geometry. And it's not going to change.
That's exactly what they did.
Yeah.
They made up their own.
Yeah, and everybody within this little paracosm has gone along with it. 10th Man sold them something, and there was a lot of flat earthers at that time when 10th Man was selling it to them. They all said it was the best thing. I mean, because it went on the back of the fallacious modus tollens that QE calls a black swan, that they all imagined that the black swan had some fantastic power. Nobody ever used it. You can't really use it as an argument. It doesn't work unless you do what Nathan Oakley does and you just silence anyone when they don't have a rebuttal to you.
On the black swan, I don't believe the guy was only a foot above the water, to be honest with you.
Well, see, that's when you say that.
He was.
Right?
It was. No, hang on. Yeah, give me 1 second. I just want 1 second. If you watch the full video, he does go right down to the water. It is a foot off the water.
When he measured that, when he zoomed in on
they didn't
the
measure nothing. They didn't measure nothing. But yeah, when he zoomed in on those oil rigs, he was a foot off the water.
I
If
can't
you
even
watch the full
imagine
video, here, I'll give you. Just type this into YouTube. Here, hang on.
Because if I hold my camera on my phone right to the ground,
This is a
it
P1000.
cuts off the surface pretty quick.
I understand. The lens on that your little phone is nowhere near a P1000.
It'll do the same thing with a P1000. It's going to cut off way before that amount of distance.
Can you humor me for 1 second, please?
Yeah, go ahead.
Just remember,
Write
this is a
down,
black
because
swan.
you may not.
This is a black swan.
Yeah, I'm not trying to force a black swan on nobody. I just want to make sure
I'm just pointing out that if you're going to say it's a black swan, you have to say what the statement is about all swans being white before you say black swan, right? So saying this is a black swan, first off, we need to know what this white swan statement is. Please.
Just better to say oil rigs picture. It is a film, by the way. So this is just one frame from film. Okay, I am off to bed.
All right.
Good night. So
thank you, Paper.
Have a good conversation.
Because as far as I'm aware, QE's fallacious argument states something about a measured distance to the horizon. Wasn't it? I think. The white swan thing. trying to find you that, Stefan, as well. I can't remember where I put it. I did have one. We got an entire video that we did, Stefan, for flat Earth math. He had a massive series where he tried to rebut the angle difference. Can't imagine what I put there. As far as I'm aware as well, the stadia hair measurement for stadiometric range finding, that's a linear relationship, right? Mathematically. A 1 degree. Where did I put it? No, I can't find it. Not that many pretty pictures. No, can't find it. I'll find it for you some point. It'll pop up within the next few days. There is an entire video, Stefan. You can just check that out. I suppose I could find that. It's the sparkles. We've got quite a few. Yeah, stadia hairs, linear. So that's how it works in reality. Oh no. Oh, it's a big list. Here's one of them. I've not even put this one out yet. It's still unlisted. Position of Polaris changes. Not too sure about that. There you go. Flat Earth Math created a straw man when we tried to explain how the 1 degree change over 69 miles. It might upset you though, because it's straight lines for both the angles and the thing all together. Yeah, we've done the Stadia hairs, but that's a linear relationship using Euclidean principles.
I'm back. I'm really sorry that I had to cut out for a second.
No problem.
Was that Gary Wabenga I was talking to?
Yes. Yeah.
Hi, Gary. Sorry, I wasn't trying to be a dick. I just wanted you to watch the whole video by BMLSB69. The full video is still on YouTube, I believe. And you can see him raise his camera up, lower his camera down, zoom in, zoom out, all of it. I'm done. Thank you, Gary.
Well,
What's that? January 27, 23.
But I wouldn't call it a black swan, Bev.
No. No, well, it's one of the problems that, you know, QE called it a black swan, but I don't know anybody knows the statement about white swans, because really it's a we see too far, isn't it? It's a hidden we see too far.
Yeah, but the even crazier part was when you said today that all horizontals are parallel. Show me that black swan. Now that's something I want to see.
Well, yeah, that's the black
Good
swan
luck.
that it should be, right? The statement is all horizontals are parallel. That's the white swan statement, the all statement. That's the only problem. That, you know, that really tells you what a black swan is. Like, we need to see the black swan to disprove that statement that all horizontals are parallel. We did say that to QE and Nathan like four, nearly 5 years ago now. A long time ago. QE told us to stay away from science. Stick to your level is horizontal bullshit. That's what he said. It's changed now after about 4 years, and they've gone through shitty modus tollens.
Randy said the exact same thing to you.
Mm-hmm. Yeah, they all get upset. That's why Ranty left, I think. Ranty went on the the beer. Nutsacked himself. He only lives down the road, but he wouldn't come out to come and see the tests at the canal. That's some of the strangest stuff. Ranty didn't even want to come laser waving with us on the beach at Blackpool. All he had to do was go to Blackpool while we were in Southport. So Tassie is in the chat here now. Tassie agrees that stadia hairs are a linear relationship. And are you saying that the light in the sky, is that a linear relationship or not a linear relationship? Polaris, 1 degree for every 69 miles. That's pretty much the same as a 1:100 ratio within the stadia hairs. They're both linear. So they both work in reality. So how can you have diverging verticals? You can't say that the relationship of the linear relationship of the stadia hairs works because of diverging verticals, because it wouldn't work. It only works when you have perpendicular. The elevation angle and the distance to GP is linear. And the stadia hairs are also linear. The stadia hairs definitely work in reality. So are you saying that it works for the same principles? I mean, you can't get the isosceles triangle like you do with stadia hairs, because everybody imagines a right angle, don't they? It's a linear relationship due to perspective. So does you imagine then that as you move further away, the reason it drops is due to perspective, like the stadia hair type thing relationship? Well, if they're both linear and they both work on geometric principles, then, and those geometric principles can be understood. Did you want to come through with anything, Rob, or are you still busy? You wanted to go over something, you said. Yeah, stadia hairs work because it's geometric principles. Blue. You need to know the size or the distance, and you can work out one or the other from each. It's a dead easy relationship to understand. Horizontal distance, vertical distance. They're both linked together within the stadia hairs anyway. We have been over this quite a few times. and we can go over it, make it a little bit clearer. We do some drawings and stuff, but not as we're talking over these sort of chats. We make some proper videos about it. It's a result of perspective. It's a result of perspective, Blue Tassie says. There's a linear relationship associated with perspective. I don't know whether most people have heard about the apparently that's curved, isn't it? The new one of the new models curves a vision. And the other model curves a straight line.
That would be Witsit.
Yeah. Well, and Shane St. Pierre.
And yeah. And then that Caleb kid. He said it too.
Yeah. Well, Brian said that Brian's not Brian's logic. Brian Leakey said he's been credited for helping them with it. Yeah, it's a bit weird, this whatever's happened within this arena. We've been talking about basic geometric concepts, and it seems that both the flat earthers and the globe earthers are both separated from the basic geometric concepts into their own whatever. They've just imagined they can do whatever they want. Imaginometry, for sure. Have you heard anything back from your conversation with Nathan and QE? That was a fascinating one. That we went over that, and again, they've not bothered trying to come and discuss with us about it. And like,
no, I made some comments
and go and say anything to them.
I've made some comments in their chats, but they either they're not seeing me or they're just purposely avoiding it.
Yeah.
Because I've been doing that for quite a while, just randomly, not every day or anything, but every once in a while I'd randomly go in there when they were talking about right angle triangles, and I would say the same thing I said on the show. Then I have some guys attacking me in the chat saying I was a globey,
Yeah, that's weird, isn't it? That, like, that's one of their rebuttals, is to just call you a glober. I've had Adam Meakin calling me a baller.
Yeah. he likes to do that.
Yeah, I think that's where they get it from. Because they've set up a false dichotomy between these two, and I think it works for each of them. It's a mutual agreement, let's say.
Sorry, I left again. I had a phone call. Fucking bullshit. I was trying to be part of the conversation, but I just missed the last 10 minutes because customers are dumb.
Hey, you can't say that. You need the customers.
I know, but they need me because they're dumb. Saying.
Yeah, Blue Marble's saying why CellNav won't work on a flat plane. Like, is that a pleonasm, Blue? I'm pretty sure that's an agreement that they've all decided within this little paracosm.
Yeah, isn't celestial navigation two-dimensional?
Well, that's what Brian's logic says.
Yeah, I was going based on that.
Yeah. Well, Blue Marble's using the term flat plane. Now, either that's a pleonasm or Blue Marble is also trying to associate flat with an orientation. Hard to tell when, you know, these guys are just making shit up. You'll have to say, Blue, next time you mention flat plane, say whether it's a pleonasm or whether you're trying to associate flat as an orientation. It gets confusing. I think QE and the flat earthers say that flat plane is an orientation of flat. So what they mean to say is horizontal plane, but because they're flat earthers and they're part of the Flat Earth Society, they just use flat for all sorts of different things. It gets really confusing. Since it's not geometric, I try not to use flat in anything, really. It doesn't help. I think it's fascinating though, right? When you've got this straight line from A to B, and they're both at equal elevation, but for some reason you can't have a perpendicular at A and a perpendicular at B with vertical and horizontal anyway. That's the strangest thing for me. Of all of the contradictions, the one they can't accept is the one that has the most geometric backing behind it. And therefore, obviously only within this really weird paracosm that we're in. Looks like Page has really taken on the geometric, the advanced simplicity, geometric understanding. It proves latitudes are circular. Tassie in the chat. Can I just ask one question? Are latitude and longitude, are they perpendicular to each other? Just a simple question. Goes for anyone as well, that really. It's one of the flaws within the Flat Earth Society, I think, is where people have to have perpendiculars but end up bending one of the straight lines that help you form the perpendicular. Doesn't really matter what model you've got either. If you make a model within the false dichotomy, you're going to have to deal with having to bend one of the perpendiculars, which would then make it not perpendicular. So the latitude and longitude are perpendicular at the equator, but only at the equator, interesting. Interesting. Right. Sorry to ruin your fun there, Paige, but I think it's time we ended. Tassie, if you do want to come in and have a chat about any of the stuff, save you staying in the YouTube chat. I mean, come on in, have a conversation, get it on record. That sort of stuff won't last forever, will it? Who bothers reading the chat? Come on in, get it documented. Let everybody know. Has anybody else got any other? Let me queue up a buster. We got something relevant. Done loads of Nathan Oakley, haven't we? What about? Oh, here we go. This is
on
Black Swan. Go on, sorry. Go on.
No, it's okay. On longitude and latitude, they're just imaginary anyhow. So how would you even have? They couldn't be perpendicular, right?
Well, they are imagined to be perpendicular.
Well, they're imagined to be, but that's it because there's not actually a line anywhere.
Well, they are.
We still just see things.
They are straight lines, aren't they?
They're only, yeah, but they're only derived from looking at lights in the sky. We should stop doing that, I said many times.
Yeah, longitude.
Yes. They're all, those lines are derived from looking at lights in the sky.
Polaris for latitude.
A light in the sky.
Yeah, and the sun, time of day.
Yeah, light in the sky.
Mm-hmm. Big light in the sky.
Yeah. And call it GPs.
Well, they're perpendicular. That's what I've heard anyway. And perpendicular is the relationship of two straight lines to one another at right angles. So if you imagine one of them curves, like nearly all flat earthers do, then you're just the same as the Flat Earth Society globe guys, because they also have perpendiculars, one of them curving. Not so dissimilar in my book. Right. Thanks for joining us. We will be back on Wednesday. Maybe tomorrow. I don't know. We'll have to see what's going on.
Thanks, Bev.
Okay. I'm going to finish with Black Swan. Yeah, thanks for joining us. See you Wednesday, and come on into Discord. That's where it's at. We've got some really good stuff going on. So come on in. See you Wednesday.
Community, please allow me to introduce to you the one you've known for all these years, your Sergeant Pepper's Lonely Hearts Black Plague,
the Black Swan. Karl Popper originated it. The idea that if you assert that all swans are white, you only need to show one black swan to debunk that as a claim. Now, in the case of our Black Swan,
If P, then Q. Not Q, therefore not P.
We showed that where you would assert way called Earth curve, we can show that the hill that's supposed to be in the way of a set of oil rigs,
not Q,
isn't in the way of it. It's behind it. It's behind it.
Not Q, therefore not P.
Hill in the way called Earth curve,
not Q, therefore not P. Therefore not P. Not P.
So based on that premise, demonstrated in the image we call
Black Swan,
we form a logical consistency argument.
Modus tollens. Holy shnikes, this is going to leave a mark.
If the Earth was a sphere with a radius of 3959 miles,
if the Earth is a sphere with a radius of 3959 miles, P,
then every distance to horizon measurement,
then any horizon distance measurement must be,
could be no more than 1.2 times the square root of the observer's height.
No more than 1.225 times the square root of the observer's height.
As laid down
here
in the begging
then
the
any
question,
horizon
proof
distance
of nothing,
measurement
perspective
must be
hijacking Earth curve calculation. Then every
you would
distance
use
to
to make
horizon
that
measurement. Meanwhile, in the Black Swan image, the horizon's behind the things that's supposed to be blocked by it.
Not Q.
Ergo, Earth has no Earth curve.
Not Q.
You don't understand.
The horizon's behind the things that's supposed to be blocked by it.
Not Q.
It's not my problem if you don't want to learn. You just
Then every distance to horizon measurement.
Not Q. Why? Because the horizon distance was greater than 9.41 miles.
The things that's supposed to be blocked by it.
Not Q.
Ergo, Earth has no Earth curve edge horizon in the form of
not Q, therefore not P.
And the Earth is not a sphere.
Therefore not P. The Earth is not a sphere.
Earth has no Earth curve edge horizon in the form of
therefore not P.
And the Earth is not a sphere.
If the Earth is a sphere with a radius of 3959 miles, P. Therefore not P. The Earth is not a sphere.
If the Earth was a sphere with a radius of 3959 miles,
therefore not P.
And the Earth is not a sphere.
Therefore not P. The Earth is not a sphere. A sphere.
The Black Swan.
If P, then Q. Not Q, therefore not P.
my problem if you don't want to learn. You just on your own.
Because that's what physical bridges that obscure fire hydrants do. Yeah, they don't do that.
No reason, no logic, no wisdom, no
Demonstrably not blowing up to vast times bigger than you'd have to have. Yeah, they don't do that.
No reason,
yeah, they don't do that.
No logic,
yeah, they don't do that.
No answers
yeah, they don't do that.
Questions.
Yeah, they don't do that.
You're just on your own.
Here is the final kill shot.
You only need to show one Black Swan to debunk that as a claim.
No, that's debunked.
Then every distance to horizon measurement.
No, that's debunked.
Ergo, Earth has no Earth curve.
No, that's debunked. Therefore not P. The Earth is not a sphere. No, that's debunked.
Because physical hills don't do that. And if you're saying there's a physical hill blocking boats and buildings, we debunked it in 2020.
So that's debunked.
I thank you.